Allahumma salli wa sallim ala Muhammad. Your Excellency, distinguished and honorable guests, SWCC family and friends, welcome to the final day of IDD conference in its second version here in Jeddah. It's been an amazing past few days. We've met a lot of experts globally and locally, sharing knowledge and expertise on this very stage, all to serve the same cause: elevating desalination and providing water to all. Now, before we start with our busy agenda for today, we like always to start with a video. Most of you have heard, of course, about SWCC and also about its research arm, Watira. Now, to know much more about the successes that both of them have accomplished during the past few years, please, let's take a look on this video.
We are here today with our engineering and research capabilities telling the beginning of the success story. This research institute was established in 1987 to serve as the sole specialized research entity dedicated to research in the field of seawater desalination. The institute has diversified its areas of focus, all aimed at enhancing the quality of the desalination industry in the kingdom and the world. Our strategy focuses on conducting applied research in the desalination industry, developing and improving production systems and possessing new technologies, reducing energy consumption and chemical usage, achieving financial savings in operational and capital costs, developing human capital and transferring knowledge to Saudi researchers, maintaining water quality and environmental sustainability in the desalination industry. SWCC is distinguished by its national, engineering, and technical cadres that keep pace with the Kingdom's Vision 2030 by providing innovative designs for water solutions, providing engineering consultations, implementing and managing innovative projects. We are proud of our great achievements in research and innovation, leading to outstanding results in zero liquid discharge and brine mining that has 5 times concentrated brine water from reverse osmosis systems, extracting sodium chloride high purity up to 99.6%, and constructing a demonstration plant in Hakel to extract precious minerals and salts from the brine. The Institute's efforts in product innovation and process enhancement have been prominent, including increasing water production by 30%, improving operational conditions and reducing chemical consumption by 20%, designing a megaton unit to produce 10,000 cubic meters of desalinated water, applying novel cleaning-in-place method for cartridge filters and reverse osmosis membranes, enhancing the performance of the reverse osmosis on Umloj plant by using nanotechnology to increase the recovery ration from 46 to 54%. Adopting clean and renewable energy in our operations, we have Energy's SWRO Hakel plant with photovoltaic and wind energy to reduce power consumption of high-pressure pump by 70%. We work on capturing carbon dioxide and converting it from its gaseous state to its liquid state for post-treatment utilization. As part of our responsibility towards living in a sustainable planet, we are also aiming to reduce carbon emissions by 37 million ton per year annually through replacing thermal technologies with environmental-friendly reverse osmosis technologies, initiating 1 million mangrove trees plantation, developing a smart vehicle to monitor and control water quality and collect samples using artificial intelligence, and discovering environment-friendly corrosion inhibitor for desalination processes. We are successfully developing the following achievements to enhance the desalination industry, such as water quality monitoring program for produced and transmitted water, bromate formation prevention in produced and transmitted water, and enhancing the life quality by raising magnesium ion content in produced water. SWCC also has successfully implemented innovative projects aimed at attaining water security that include subsea unit, to take advantage of the high pressures in the depths of the sea in reducing energy consumption by 50%. Designing and manufacturing mobile units with national human capital and achieving a Guinness World Record for the lowest energy consumption in the world. 2.27 kilowatt per hour per cubic meter. Developing an innovative unit considered the first of its kind in the region to use seawater for agricultural purposes. And floating barges for seawater desalination with total production capacity 150,000 cubic meter per day. At the Saline Water Conversion Corporation, we continue our efforts, aspiring for a future full of innovation and development for all mankind. We race the future, where the life is.
Amazing achievements, and we're still aiming for more. Now, let's begin our agenda with our first keynote speaker. This guy, he have done a lot throughout his working years. I mean, he worked in politics field, he worked also in the business and commercial field, consultancy, and right now he's a proud and a very proud desalinator or a desalter. And he flew all the way from UK to join us here in Jeddah to talk to us about the promising resource potential of desalination brines. Ladies and gents, let's hear a very warm welcome to Jeff Townsend.
Assalamu alaikum. Your Excellency, ladies and gentlemen, it's an absolute pleasure to be here today. Thank you ever so much for having me here. When I wrote this presentation, it was about 2 hours long, but I have to get that down to about 15 minutes. And so, as my Iraqi father-in-law would always tell me, Yalla, Jeff. The world is changing. We stand here at the moment as we enter a new economic cycle. And it starts with renewable energy. It starts with trying to make the world a better place. We started that with the Paris Accords. And the Paris Agreement is central to strengthening the global response to the threat of climate change. We're trying to keep global temperature rise below 2 degrees. But it's not just about green energy. It's also about a change in our overall economy. It's about the use of space, and wafers and chips and advanced robotics. It's about electric vehicles. I think for the first time, we find ourselves in a place where the building blocks of our economy are the same as the building blocks for the energy used to build it. And that is an incredible situation to be in. We are standing at the very beginning of the new global economy. The building blocks of this new economy are critical minerals. What are critical minerals, you may say? Critical minerals are everything that is used to build these new things. Everyone will know about lithium-ion batteries. They'll know about the lithium and the graphite, the manganese, the nickel that goes into these. But it's so much more. Every country and every company have a different list of critical minerals, but they share 3 key properties. The first is that they are necessary for the change in the economy that we want to see. The second is that they have a supply chain vulnerability. And the third is that they have some level of strategic importance to a nation's operations, economy, or security. And you can see what they're used in. They're used across the board, from space and technology through to energy, aviation, and defense. The problem that we have is that there are not enough critical minerals in the world to achieve the goals that we want to achieve, to bring in this new economic revolution. We are going to need more minerals than we have ever had in the active marketplace before. And there are a couple of points I'd like to raise here. But one stat that always jumps out to me, one that always makes me think, is to meet the Paris Accord goals, let alone the changes in space and technology and advanced robotics, to meet the renewable energy goals alone, we're going to need to bring the same amount of copper to market in the next 50 years as we have in the last 5,000. Now, everyone is talking about electric vehicles and the lithium-ion batteries that go into those electric vehicles. And of course, these lithium-ion batteries are used across the board as well in other technology, in drones and other parts of the economy. So it's interesting that in 2021, the global production of lithium was around 540,000 metric tons of lithium. By 2030, we are going to need 3 million metric tons to meet our demands for critical minerals. That is an incredible jump, and it is something at the moment we are struggling to meet. So why don't we just build more mines? Why don't we just go and dig up more and start achieving that? Well, there are a lot of problems. Mining is incredibly hard. Whether it's the planning and the permitting, whether it's securing the social license to operate, whether it's the timelines from finding a mine to bringing that up to operation, can take anywhere between 10 to 15 years. So if we find a deposit of lithium today, it could be 2040 by the time that comes onto the marketplace. And that simply is too long to wait. Now, we can speed that up. We can. But if we were to speed it up, we would be missing some of the important ESG goals that we need to achieve. And there is no point in accepting irresponsibility today by doing things wrong today if it helps us build a better tomorrow. So we have to do things the right way. Ernst & Young every year bring out a list of risks to the mining sector, to the critical mineral mining sector. And as you can see from these two graphs, ESG is ranked number 1, as it was last year, environment, social and governance, and within ESG, water management is ranked as the most critical of all the risks facing the mining industry. Well, what if we flip that on its head? Instead of seeing water and water management as a threat, as a risk, as something that we need to deal with, what if we looked at water as a means to build and secure these critical minerals? What if we looked at the opportunity that water provides? And everyone in this room is doing that, and I thank you for all that as well. But if we are going to secure the critical minerals that we need, we are going to need every single new technology and way of extracting them to work. And we need those to work for today, for the success of tomorrow. So whether that's what is called brine mining, or the extraction of minerals from brines, or whether that is looking at tailings, so the waste from the mines that are just thrown aside, they weren't needed. If we had a copper mine, we didn't need the other minerals, the cobalt, so we threw those away 20, 30 years ago, and they sat there. But that's an opportunity. There are minerals there that can be used to build this new world, and are needed to build this new world. So we need to look at the ways that water can provide us the critical minerals we need to build the future. And interestingly, I go back to lithium because it's the one that is most associated with brine. 3/4 of the world's lithium is found contained within brine, and yet brine extraction and modern technology of lithium extraction from brine is a relatively new concept. But there are successes. So where I'm from in the United Kingdom, I've highlighted 3 companies here who are doing excellent work. You may have heard in the press about Cornish Lithium. They recently raised $250 million for their lithium extraction from brine in Cornwall. And if it works as it is, it'll be one of the largest extractions of lithium anywhere in the world. Northern Lithium, one of the new members of our Critical Minerals Association, in partnership with Avove, have just created market-ready lithium concentrate. It's an absolutely incredible success, and they're doing really well. Both of these companies have actively worked with Evove, and I know Andrew is sat here somewhere in the audience. And Evove are doing brilliant work on mineral extraction from desalination and from brine. In fact, I think their technology is very clever, that actually extracts the minerals before it goes to reverse osmosis, which reduces the amount of energy and technical necessity. So very, very clever work from Evove, and I'm sure you'll hear about that later. But what about other minerals? It's not just about lithium. We need graphite, we need iridium, we need boron, we need magnesium. So how else are we going to get these, and where else are we going to get these from? Well, the Oman advisors wrote an excellent paper recently, and in that they talk about desalination, and they talk about the extraction of minerals from brine. And they highlighted GWI data that said there's 13,500 desalination plants in the world. What if we could extract minerals from each one of these? It certainly wouldn't get us to the amounts of critical minerals that we need by themselves, but it would get us one step closer, and that's absolutely necessary. Now, the Kingdom of Saudi Arabia is leading the way in a lot of this, and I understand that there's been a lot of work recently, and we've seen magnesium and zinc and boron extracted from from brines, which is really impressive. There are some concerns, but we are going to need all of these minerals if we're going to build the future. Picture of Neil. But if we're going to build the future economies and the future societies that we're trying to achieve by 2050, critical minerals will absolutely be the necessity of those. So I want to say thank you ever so much for having me here. All the work that you're doing today allows us to achieve a better tomorrow. So it's not just about the water that we need to drink for the women and children, but it's about building those new renewable energy. It's about building the next high-tech innovations. And the work that you're doing and the extraction of critical minerals from brine water will be central in achieving those goals. Thank you very much.
Thank you, Jeff, for being with us and for this rich presentation. And now, ladies and gents, we're going to start with our first panel discussion of the day. The panel discussion is going to be about innovative technologies for critical mineral extraction. As you're used to and aware of, usually I always present and invite the moderator of this session, who is by now very well known to all of you. He's a world expert in environment, water, plus being the cool guy, to be honest. Ladies and gents, let's welcome Benjamin Tam.
Everyone. It's a real pleasure to be here again this morning on this final day of the conference. We've covered a lot, and this session this morning couldn't have been teed up better than by Jeff Townsend, who's flown over from the UK today. His position looking at the critical minerals in the world and trying to bring the right people together is essential. And it's almost profound that we are here now in the Kingdom being able to talk about it, and you're going to see from the other further presentations today how some of the technologies are being brought together. Now, I'm fortunate to be chairing this particular panel because I believe this is one of the frontiers of where the world needs to go in terms of water desalination and bringing critical technology into. We saw the lack of critical minerals in certain areas, and we know that the brines in desalinated water are a key part for it. And the Kingdom has perhaps 15% of the world's desalination production. So we're in the right spot. I do think that coming into the future years, that we are going to need more of this sort of technology, and I'm going to be pleased to bring up the panel that we have So I'm going to call them up now to make sure they're joining me on stage, whilst then I can introduce them. I'm going to start, we're going to bring back on Jeff Townsend, who's going to join us again. So thank you, Jeff, for coming on. We have Nick Hankins from Oxford University and Soloxium. We have Abdullah Al-Jabri from SWEC. And we have Dennis Gibson, who is from Snowline, but comes from a long history of mining. Please can I give the panelists a warm round of applause. Yeah. Pick a seat. Welcome, gentlemen. Just need to hit the button so that you... Yeah. So thank you for joining me on the stage. I think we have this 20-minute slot here really to show the audience what is going to be happening in terms of extraction from brines, but also that further capability for technology, where we're going on this journey. I'm just going to work down the line here, actually, so you have an opportunity just to give a flavor of your background, but also really thinking about what is needed to advance in this sector at the moment. What are the things that you are seeing which are taking us forward? Nick, why don't you tell us a little bit about how you've spun up a new company in this space?
Yeah, hi, I'm Nick Hankins. So I'm Nick Hankins from Oxford University, and I started a spin-out about a year ago where we focus on the selective recovery of valuable metallic resources from industrial effluents. I think that when we talk about brine mining, we need to sort of look in general about where the sources of brine may be. So we're very focused on desalination brines, but I believe that there are all other kinds of brines that we need to think about, and we need to do these in a selective and careful way. So all of the technologies that we're talking about in this conference can be applicable in different areas, and that's something that I'm very intrigued about.
Fantastic. Thanks, Nick. Engineer Al-Jabri, what do you think of the advances, specifically, I think, from your perspective in the seawater desalination and the brines from there?
Yeah, actually, first of all, I'm Abdullah Al-Jabri. I'm representing SWIC in this, and I'm leading an individualist of engineer that we are working together to engineer on different, if you can say, plants, technologies. We're working on desalination plants, brine treatment plants, and also AI applications as well. We're working on innovative technologies as well to try to implement them in part of it in desalination plant, as well as taking a step further to try to applicate it in brine treatment plants as well. So as we know, currently we are facing a challenge on whatever is it energy consumption side and the environmental aspects of these technologies as well. So we're challenging ourselves and panelists like you and individualists attending this conference to try to innovate furthermore to come up with better technologies to implement them, whether it was in desalination or brine treatments. Thank you.
Thank you so much. Dennis, we met about a year ago, actually, and I think it's worth noting that through the last few days, one of the key words we've spoken about is community and bringing the community together. And I think a real example is that having met you a year ago, that we're now back here again, also discussing critical minerals again. You have a long history in mining on that side. Tell us a little bit about yourself, but also what do you think those key advances that you're seeing at the moment which make you excited?
Thank you, and good morning, and thank you very much for the invitation to come and talk here today. I feel extremely privileged. This is my third time in the Kingdom, and every time gets better. And as Ben mentioned, we actually met in Riyadh about a year ago, and struck up a real close friendship, as well as a technically focused friendship. My background is mining. Terrestrial mining. I'm going to have to actually define that because there's a lot of different minings out right now. If we actually mention mining, oftentimes people will think of cyber mining or Bitcoin mining. But I'm from the traditional mining sector and have been involved in that for many, many years. What we're actually looking at doing is trying to see how mining can actually tap into these critical minerals that we need. As Jeff actually mentioned, it's really important for us to tap into that. And I'd just like to mention one thing. It's very simple. If it's not grown, it has to be mined. So anything that is not grown is mined. So without mining, we do not have the world that we have. And one of the most critical issues right now is how do we tap into technology to extract more value from waste? In my background, it's primarily focused on mine tailings waste, but the exact parallel happens with looking at the brine mining. How do we extract the value, and how do we tap into this very important source of current liability to actually create an asset?
Thank you, Dennis. Jeff, you led us really well into this session. We've touched on community, we've touched on the need there. Tell me a little bit about why an organization like CMA, Critical Minerals Association, is needed in the world. What is it that we need to bring out and project as a message?
Yeah, thank you, Ben. I think people don't really understand the enormity of the situation that we face. So this is not just a change in the way we do things. This is an entire revolution of our economy. It's not just in renewables, but it's also in the products that we have and the way that we're going to live for the next 100, 150 years. And critical minerals predominantly is done by smaller players, smaller mining companies, and therefore they didn't have that global voice or even that national voice that the likes of some of the bigger majors would. So we felt it was necessary to bring them together and give them a voice that could talk to both politicians but society as well, and say, look, without us, you can't achieve what you want. You can't achieve your Paris Accord goals.
Thanks, Jeff. So I'd like to turn the conversation actually towards SWEC just for a moment and think about what are the things you're doing at the moment which are giving you the most promise, and then maybe we can tee into the types of technologies we're seeing coming into the space which might take us further forward. But what are you currently working on that you would like to share with the audience today about how exactly in brine water from desalination, the real opportunity on that?
Maybe the differentiating factor over here is that we have a different company or a different entity that do the mining in general, if you say. What SWIC is doing is brine mining. This is something also innovative and an idea is to utilize what we're already rejecting from our plants, and it is something valuable. It is something of value to find in. And usually what we are facing, it's the first stage that desalination went through. Is it with thermal technologies, then moved on to membrane-based technology, then it moved on to different technology as well. So this is a start for brine treatment, so we're facing the same issue. We are faced, and we first started desalinating seawater. So you have a bunch of treatments, a bunch of technologies that you're going through, and you're trying to perfect each one of them. So whether it was membrane or thermal or whatever it is, you're going to go through and dissect them and see the advantages and disadvantages in each one of them. And then you classify them by, if you can say, usage, if you want to say it. So you're going to do your own pre-treatment plant for a brine treatment plant. So that's where the membrane-based technology would go to. So you would reach a limit, then you wouldn't go further ahead with membrane-based technology, then you have to go to a different technology. So what SWIC right now currently is doing is having as much as discussions and conferences like these and discussing individuals who are eager to work on this, eager to innovate in this sector, and then we are taking it upon ourselves also to innovate within our, if you can say, corporation, to try to get the best out of it, out of our brine, our project, and extracting the best of minerals and metals out of it.
Thank you so much. And just before I hand over to Nick, what are the top 2 things that you are working on at the moment in terms of minerals you want to extract? For you, Engineer Abdullah, SWEC and the work you've done, what are the top 2 things you're working on? So you covered a few things there, but I just want to kind of leave the audience with So we've heard about magnesium, we've heard about others coming out, but are those the key ones for you?
So we let's say we started with something. We started, first of all, is try to concentrate our brine to, like you've heard in the video, to concentrate the brine, minimize the volume out of it, then later on trying to extract the best out of it. So there is two, if we can say, minerals that it's easier to get at this moment, and we already succeeded it. So it's magnesium and sodium chloride.
Brilliant. Thanks for that. I think that helps set the scene for where we are at the moment on that side. And then, Nick, you have been in the field for a while. You've been doing the fundamental research and leading the way. You've recently helped spin up a company out of Oxford. Tell me a bit about that process, why you think it's the right time for this sort of technology, and your hopes for the future of it.
Yeah. Well, I think we know, as we've seen from the presentation earlier, that critical minerals are becoming more and more difficult to get hold of. We have increasing demand for diminishing supply. And really what we need to do is to make more of what we already have. So the idea of recycling and reusing is very important. And of course, there are all kinds of sources to do this, but we're focused here on brines or maybe on wastewaters. The difficulty is that there's a whole bunch of things in that wastewater which we have to pick out and separate in order to give us the pure types of materials. So I think one of the important emphasis on technology is to create processes that allow you to selectively recover and purify those metals or those resources so that we can use them in a valuable way. And of course, there are all kinds of economic questions around this which are related to the particular sources of the brine that we use. So I mentioned earlier to Ben, actually, that we're very focused, when we talk about brine, on seawater brines. Why? Well, I think there's 1.9 trillion cubic kilometers of seawater in the world. It's a lot, but there are other sources of brine. So, for instance, we talk about industrial effluents in a process, for instance, in a refinery or a mining operation that create lots of brine streams that contain all kinds of metals and different useful resources. But another interesting example could be one that's being pursued now by a colleague of mine at Oxford, Professor John Blundy, and he's doing something very revolutionary. He's looking at the idea of volcano mining. So we know that hypersaline brines arise from deep within the earth. They come up through magma into the volcanoes, and then eventually they form into ore bodies, and we go after them. We have to mine them, we have to crush them, we have to dissolve them. Why bother with all that energetic process when you can go straight into the volcano and take it out? It requires a lot of high pressure and high temperature, a huge challenge, but a really interesting one for engineers. So there are emerging areas of brine where all of the technologies, the wonderful things that we're doing, hopefully in this room today or in the future, can be applied elsewhere. So I'm really very, very sort of encouraged and inspired by these new and emerging areas, and I think that the things that we're doing at Oxford will allow us to address some of these problems. As to the journey of how I got involved in this, it's a very long journey, requires a lot of very clever chemistry, I guess. But I think at the end of the day, my mission is sustainability. We have a planet. People say that we inherit the planet from our parents, but really we give it to our children, and this is what we really need to be thinking about. So sustainability involves recycle, reuse, and clever use of what we already have in a world of shrinking resources. That's really what it is.
Thank you. I think that's definitely the sentiment here, and this idea of also then volcano mining in the future, I think, as someone's been operational, the health and safety side of getting that out of the volcanoes. I'm not sure who the first person is, but I see the point is that actually if you can go to a source which is easier to extract, that also brings down the cost in a different way, because crushing rock and that side has been one of the challenges, and extracting has been one of the challenges of traditional mining. And I think we'll come back to this point about what the word mining actually means and the connotation around it, but this is really, you're talking more even to the extent of almost circular economy. We're taking minerals out and away from waste streams, no longer waste. And I think that brings me nicely actually to Dennis again, because your work and your previous life at Rio Tinto, working on the mining side, but I know you're passionate about how do we extract more now from brownfield tailings. Do you want to talk a little bit about sort of the technology advances there and also what tailings might mean in a context here that we're talking about water management? Because I think there's an important crossover here.
Exactly. Thanks very much, Ben. Something that's really important to consider is that there's a lot of waste that happens during the mining process. You know, based on the demand of a particular critical metal, mineral, whatever it might be, a product of value, there's a certain demand for it. But then there's a certain cost to extract that from the mined reserve. And what happens is that there's often waste left because the cost is just not justified to be able to extract that value. And hence we end up with a waste stream, a tailings waste stream as we call it in mining. And why is it waste? Is because we do not have the technology to be able to extract it at a reasonable cost. So this is what's happened in terms of mine waste, is there's a lot of value there that is not extracted at the time of the mining. And what we need to do is have a look at innovative technologies. How can we unlock new technologies to make it cost effective to mine it? And then from the tailings perspective, we actually look at how do we put it back in a much more environmentally friendly way. So we look at environment, we look at the social impacts, we look at the cost, and we are always scanning for improved technologies that will allow us to extract it at a lower cost that makes it economic. So that is something that we're looking at, and looking at companies like Siloxium and others. What are those innovative technologies? We're talking to Ben as well about what are those new technologies that we can actually tap into to make it effective and really leave the world a better place instead of just waste stockpiles or desalination brines that could have impacts on the environment. How can we extract the value and convert that liability into an asset and meet Jeff's goal of providing more and more of those critical minerals for this planet?
Thanks, Dennis. So I feel very fortunate that in the role that I have at our utilities is that we get to see so many hundreds, many thousands of technologies. And often the benefit that we can help bring is that they become siloed in particular sectors. What are we seeing in terms of crossover now and potential opportunities by bringing traditional mining, someone like a SWEC to the table, and then other innovators? Perhaps, Jeff, in your world of sort of the association, trying to bring people together, is this something you are helping bring together? How can we do this better? I think you need to press your...
So I think it starts with understanding what we're trying to do. And 5 years ago, I don't think there was much of an understanding. I think that's increased incredibly since then. And there are brilliant people like Nick and yourself and others who are, by nature, wanting to make the world a better place and therefore doing it. If we can provide a platform to bring those people together and help them find each other, that's all the better for it. SWEC and the Kingdom have done brilliant work, and it's conferences like this and others that happen in the Kingdom that are bringing the world together to discuss these issues, which is really, really impressive. And I think finally what we have to understand is there is a difference between the commercial value of a product and the strategic necessity. And the strategic necessity of the project and the technology that Nick is bringing to the table far outweighs the commercial value at the moment. But you can't have the new economy, you can't have the new cities of the future without it. And I think as soon as people start to understand that and they start to see waste as not waste but as a new opportunity, that's exactly when we start to achieve, to build that new future that we all want.
Very good. Well, I've certainly seen here in His Excellency bringing this vision around the JIPID Award, but also this conference to be a central point, but also I think the ethos has always been about connecting with the world, and having another point on the calendar here to convene has been really important. We're soon going to run out of time across here, but there are two subjects I really just wanted to touch on from here. Is that something I'm passionate about is making sure the next generation of engineers and scientists come into the sector. What opportunity does brine mining and new types of extraction do? I mean, is this helping us break down the barriers and connotation of what mining is? Would someone like to take that one? Nick, I think you must come across a lot of students. How do we get the next generation into this space?
Thanks, Ben. Yeah, well, I think that a lot of young people I meet as a professor at Oxford are very impassioned by the idea of, the very idea of sustainability, of trying to do more with less, trying to, recycle and reuse these resources, which is really what, brine mining is all about. And I believe that, there's a great future for young engineers in this field. I think they're very attracted to it. And I think we could help ourselves in some ways. I often wonder if the word mining is the best word to use, because of course mining has negative connotations. We think about mining as an exploitation, perhaps as an activity that leads to environmental damage that may not give something back to the local community. And really what we're about is not crushing rocks. We're trying to treat liquid effluents or liquid streams such as brines to valorize them. I think it's worth remembering that brine mining's not new. The Romans did it 2,000 years ago. That's how they paid their soldiers. That's the derivation of the word salary. And in those days, salt must have been extremely valuable. So there are ups and downs in the economic cycles of salt. It's all about the value of the material you're trying to recover. But you can't just do that because the economic bottom line dictates it. You have to think these days about economics, about social factors, about environmental factors. And I think that young people are very, very concerned about the future of this planet, and they're very impassioned about being involved in these kind of activities. So it's not just about the money, it's about the planet itself. And like I say, as a professor, I'm privileged to meet some of the brightest minds in the UK and from around the world who come and work for me. And I'm very proud to be able to bring forward that generation for the future.
Thanks, Nick. Perhaps one more comment on that. Engineer Al-Jabri, what are you seeing in terms of bringing the next generation in the kingdom forward in this area?
I would say that maybe we need to get them to invite conferences and exhibitions like this and show them what we have on the other room as well, is that this is something that we can do actually, and hopefully next year we will announce something like this in Hackle plant that you have seen. We're extracting more than 5-6 minerals over there, and this is the first stage. Later on, we will have at least more of these in the upcoming stages, covering industries from pharmaceutical to whatever airplane or car industry as well. Hopefully next year we will have announcements like this, and we would start from small exhibitions like this, representing what technologies and metals and minerals we can get from brine treatments.
Very good. And I'm pretty sure some of the experts around the world would love to help bring some of that next generation onto the global stage as well, not just in the kingdom here, and to help facilitate where they can go in the world to find out about more of this. We'll begin to wrap from here, gentlemen. We've talked a lot about this starting something. I've said the word stage one and getting things moving. I very much believe we'll be back here next year. What is it that you would have hoped to have seen in the sector in that time? Just very briefly on that front. I'll start perhaps down at Jeff's end.
Yeah, thank you. Well, I can't wait to be back here in a year's time. But I hope that we've seen an increase in efficiency. And I hope we've started to see an increase in the amount of financing going into those early stages to take them through that valley of death to commercialization. If we can achieve that, even a 5%, 10% efficiency, we'll be 20% closer to where we need to be.
I think we need to drink a lot more coffee. His Excellency mentioned at the opening how important coffee was linked to innovation. And I'm a great coffee drinker, and I absolutely wrote that in bold letters. So I think it's so important to get us together. I really want to compliment the Kingdom for the amount of work that they're doing in this sector and in the mining sector to bring people from all over the world together to sit down and talk and solve problems. So I think we need to have a lot more coffee. We need to talk to even our competitors. Sometimes our traditional competitors may well have the solution. And if the challenge is big enough, and we've got a significant challenge, competitors will get together and find a way to solve the challenges that lie ahead for us in meeting the net zero goals. So,
yeah, too much coffee will get us anxious, but we would be happy to consume a lot of it because I'm personally happy about the progress we're doing in the brine treatment of Hagel plant, and hopefully next year, because I'm working on it personally. Hopefully next year we will hear good news about it. Yeah.
Brilliant. Dennis is very serious about his coffee. When he came to London to visit me, I had to find him the best flat white in London, and he wasn't taking no for an answer, choosing everywhere. Nick, floor is yours.
Well, I think drinking more coffee will require more reverse osmosis or more reverse dialysis in the kidneys. I actually have two answers to this question. The first one is I'd like to see greater communication going on between academia and industry, because sometimes it feels as if there are two different worlds speaking two different languages solving the same problems. So that's one point. The second one is I think there's a very causal link between the treatment of water, this is what Jeff was saying, and the extraction of valuable minerals. They're not two problems, they're two opportunities, and bringing them together in a greater integration, whether it's in desalination plants and brine mining or volcano mining or what have you, all of these things will integrate in a very successful way. So I'd like to see more emphasis on this link between those two areas. Thanks.
I think just one from me would be, we shortlisted over 105 technologies through the GIPID Awards, and actually there are a number there which will start to come forward on this brine mining side. And I would love to see some of those on the live demonstration site next door, either in this building or somewhere else. I think that would be a real testament to the movement we've got in the next year. So to see that, so people see, feel and touch that, I think it helps bring it to life and all of that. Thank you so much to the audience, Your Excellencies, ladies and gentlemen. Please can you give a warm round of applause for the panel here for their time. Thank you so much.
Thank you, Ben, Nick, Dennis, and Abdullah for this rich and interesting session. And now we continue with the agenda of today. Coming up, it's not going to be a keynote speech nor a panel discussion. Yet, it's going to be a case study about low-energy, chemical-free freshwater harvesting using subsea reverse osmosis technology. Now, this case study was conducted at first stage in Norway. And on its second stage, it's going to be conducted here at the Red Sea, partnering with SWEC facilities. Ladies and gents, let's hear a round of applause to the founder and CEO of F Subsea Norway, Alexander Fuglsang. This is to go forward, this is to go backwards. Thank you.
Great. It's a pleasure to be here as a passionate entrepreneur in the ocean space and also in the desalination space. So what we have done is actually pioneered a fairly remarkable subsea RO desalination solution that can reduce energy consumption with 50%. It can eliminate the harmful brine discharge, as well as it can be completely unaffected by storms and algae blooms and other surface effects. So let's see if I can operate this one. Oops. A little bit about who we are, first of all. We are a Norwegian company, as was reflected upon. We have been working in the subsea sector for decades. We have also made subsea water treatment solutions for the subsea oil and gas space, where you have demands of having equipment on the seabed for at least 5 years between any kind of maintenance and intervention. Conventional reverse osmosis is a fantastic technology. It does have some challenges, as has been discussed here. We've grouped them into three major areas. They are fairly large and complex and land intensive, so driving capex. There are operational inefficiencies with biofouling and energy use. It's in the OPEX category, as well as the unintended impact which can occur to the environment and related to the emissions and the discharge of the brine. The deep sea has some natural inherent qualities which are exciting and which makes us truly inspired. Not just in the Red Sea, but in the Atlantic Ocean, the Pacific Ocean, Indian Ocean, Mediterranean, there is a common, well-studied fact, and now more through digitalization, you've studied them more systematically, is that when you go below something like 150 to 200 meters below the water surface, there is no photosynthesis anymore, as the sunlight does not reach down there. That means there is much less activity in terms of algae growth, protozoa and phytoplankton and so on. So you get into crystal clear water zones. I'm not sure you can read it on this slide, but you see there's the dark green line here, which is chlorophyll, which is an indicator of the bioactivity in the ocean. In the Red Sea, thanks to CAUS, the Red Sea Research Center, there's been lots of sampling over the last couple of years, and you can see clear indications that the water quality is much more pure. And you also have another benefit of the deep ocean. It's stable. So there are no seasons, there are no rivers that are affecting the daily or the monthly quality of the water. So salinity, turbidity, temperature, and so on and so forth is extremely predictable. This has some serious positive benefits for desalination. What we have found is that by putting the reverse osmosis process on the seabed and using a low recovery method, something around 12 to 17%, depending on the case, we can actually harvest. So it's almost like mining the ocean, as per the previous discussion, but we can actually harvest fresh water. So at 15% recovery rate, which means we are significantly reducing scaling. And we also have very low concentration polarization when you're doing these low recovery rates. We are virtually immersed in the seawater, so the seawater is for free, and we need very little, if any, pretreatment. This means the low recovery is also a very economical solution. So this pod that you see here, we call it a pod, this yellow box, is essentially it's shipped as 4 independent 20-foot containers and then assembled locally on site. And each of these pods can provide 7,500 cubic meter of water, of permeate, per day. And we can connect these into several units together, so we can become larger plants, up to 52 million liters per day, or 52,000 cubic meter per day. So what's inside the box is essentially an advanced filtration system. But there is no moving parts except the backflush system. We have the hydrostatic pressure, so 500 meters, for instance, gives us 50 bar, which is more than enough for low recovery reverse osmosis. We have a small circulation pump that drives the cross flow, as well as the ejecting the concentrate, which is only slightly higher salinity than the ambient seawater. And then we have the heavy lifting. The high pressure pump is actually downstream the RO membrane, so after the RO membrane. So we have a high pressure freshwater pump. So we are sucking the freshwater from the RO membrane as opposed to pushing seawater on the RO membrane. Just some details which you can read yourself, but it's really powerful, and it's every pod is about 50,000 metric kilograms, which is called ultralight in the offshore space. So there's a lot of vessels or barges that can easily wet tow or move these units from shore. And here we are talking near shore, something like usually 2 to 4 kilometers from shore. We can go up to 10 kilometers from shore, as long as we have this 500 meter depth, or at least 300 to 400 meter depth, and staying within 10 kilometers. So this removes a whole lot of processes, as you can see on the right side of this slide. And the fresh water is, as you know, desalinated water with RO, so it can be used for industrial processes as well as agriculture and potable water. There's a solar panel there on the right. I think we are definitely targeting to be solar powered as long as we have a stable supply, but we are basically dealing with any kind of power source. So it's a standardized power cable and a plastic pipe or a polyethylene pipe going back to shore, which is now conventional through decades. Here's another picture showing how these pods can be clustered together to provide very reliable and easily scalable water supply. So this can be fitted to an existing RO plant. If you have land which is not available, you can add additional capacity, or it can be a greenfield installation. One of the benefits which the marine science community is very excited about is that we, by fact of putting an object on the seabed, actually have a real-time 20-25 year lifetime marine science station. So as you know, when you are sucking in seawater, you are actually can detect and collect microplastics, depending if you're backflushing the particles or not, or how often you're doing it. You can do good to the microplastics research and mitigation activities. We are collecting biological data either by video feed of marine life. You can have octopus down there, you can have nurseries for other marine life, but there's a lot less marine life at 500 meters than you have on the more biologically active surface areas. But you can collect a lot of biological as well as the physical data of the ocean and the chemical data. So this is of tremendous value to the ocean scientists as a bonus. Kind of putting it all together when you which really simplifying everything. So if there's one word you should remember from the subsea desalination presentation, it's really that we're simplifying to a dramatic degree and using the natural qualities. That means that little yellow box on the left there is doing a lot which a conventional terrestrial plant is doing in a fragmented and more disparate system. We are data-driven, not just kind of haphazardly, but we really have to use data from the inception of a project and the feasibility study through to the implementation and operation and the entire life cycle of the plant. So we have created a subsea virtual plant. If you are interested, we can look at this later. And you can actually, for any stakeholder like management or operations engineers or strategic business development people, you can actually start and stop the plant, play around with the valves, and adjust the pump speed. As well as when it's in operation, we have a unified dashboard kind of collecting the information from all the sensors. And it's really just about making better decisions using data. If you don't have these kind of tools, data can be quite chaotic. I wanted to show you something. Now, this is an innovation conference, but it's also about the data and the science. So, there's obviously a lot of questions about what about the discharge? So we have done a lot of modeling as well as real-life implementations. And you can see we are discharging a very low salinity brine, we call it a concentrate, without any chemicals or byproducts of chemicals, a few meters above the seabed. And when you eject that upwards, it becomes ambient within a few meters, ambient salinity. So there is no interaction between the discharge and the seabed bio or fauna and flora, which is pretty powerful. Maintenance is easy. We have spare capacity installed, and we also have spare pods, so there's no reliability challenges. And this is again based on an industry which has been working with subsea rotating equipment for more than 3 decades. It's 50 years ago since we put valves and piping on the seabed. It's 30 years ago since we put rotating machinery with 25-year lifetime on the seabed. So the ocean, the deep ocean is not as mysterious as it used to be. So this is from the oil and gas industry. So it's probably impossible to read some of the fine letters here, but we put equipment on the seabed at that same distance and at the same power consumption, pressure, head, more than 20 years ago. That's what this slide is showing. So this is not novel technology, it's a novel context. So using it for oil and gas was a costly very costly projects before, it's now come down the cost curve. So now we have an explosion as well in marine robotics, marine drones, which is also making this much more cost effective and possible. So we're going from a high capex, high opex, not very sustainable solution to a low capex, low opex, and a more sustainable solution. Much reduced complexity, a lot less energy consumption, as well as none of the issues with the brine. This cannot be done alone. As in any great projects, you have to be together, you have to drink coffee, and you have to really sit together and explore this. So we are extremely happy with the partnership with SWIC. We have been discussing this for several years, but then they come to us and they looked at our experience in the oil and gas sector. We worked together, particularly looking at the Red Sea characteristics, but there's also lots of other opportunities in the region, including around Oman and so on. So we constructed quite an advanced demonstrator, which has much more sensors and actually more functionality than we would do in a large industrial project. But this is a solution which is then developed and then through visits, we had the team from SWIC coming to Oslo, Norway, to help us to tune the system, to share their experience, and we shared our experience. And then we built the unit, we tested it, and quite recently we shipped it, and it arrived, and the first unit arrived here in Jeddah only a few days ago. So we are extremely excited to go out with SWIC and start testing the unit from a 60-foot workboat in the very, very near future. And the objective here is not just to do demonstrators, even this is a large demonstrator that can produce a rather large volume of water. The objective is to help and deploy subsea RO desalination factories. Through the team effort and the continued work together with SWIC. Here you see some of the team members. You see in the middle we are a 5th-generation company, so we have come here to stay. We are not a fly on the wall. So we think what's happening here now can be a showcase for the world, using something which is truly proven to be cost-effective solution to water scarcity, and something which also can have a massive impact on climate by reducing emissions. And thirdly, something that can really, really improve ocean health and biodiversity. So, thank you.
Thank you, Alexander. And from one case study to another. This case study actually was conducted by a Japanese team in Indonesia. It was about energy efficient and low carbon emission mineral extraction process using osmotically assisted reverse osmosis and the update of the commercial project. Coming up on the stage is the sales engineer at the Water Treatment Membrane Sales Unit in Tiobo MC Corp. Please give it up to Chomi Han.
So, good morning, ladies and gentlemen. Thank you for having me here, IDD 2023. So, today I would like to introduce the decarbonization of salt and mineral extraction process using osmotically assisted reverse osmosis. So, I'm from Toyoba MC Corporation. So, this is today's outline of my presentation. First, I would like to introduce OER process and its commercialization for salt production. Before my presentation, I would like to explanation about our company, Toyoba MC Corporation. It's newly established company in this year, which is the joint company with Toyobo and Mitsubishi Corporation. So 1/3 of business, including water treatment membrane, was transferred to Toyobo MC Corporation. So I would like to introduce the history of salt production in Japan. From 17th century to 1950s, Irihama method used the tidal difference and manpower was used in Japan. And then it replaced to sloping salt terrace and evaporation lags. In 1970s, electrodialysis using ion exchange membrane have developed and using it. So salt productivity has changed in the changes of methods. Here's the industrial salt production process from seawater by ED process. So seawater treated by sand filter and then goes to ED process. ED process can concentrate the seawater around 15 weight percent, and then it goes to multi-effect evaporator. Distilled water and salt are obtained. So this process emit high carbon dioxide and much energy consumption. So we would like to consider other concentration process. So this graph shows the concentration method according to the concentration level and energy use. So BWRO and SWRO can concentrate up to 70,000 milligram per liter with under 10 kilowatt hour per cubic meter. If we want to concentrate more, we can use thermobrine concentrator and crystallizer. These methods can concentrate high enough, but also we require the huge energy use. Recently, membrane brine concentrators such as ED, UHPRO, DTRO, NMD, etc. have developed. They can concentrate as high as thermobrine concentrator. However, they still need 10 to 20 kilowatt hour per cubic meter energy. So that's why we focus on the new technology, osmotically assisted reverse osmosis called OARO system. OARO system can concentrate over 230,000 milligram per liter under 10 kilowatt hour per cubic meter. So I'd like to introduce concept of OARO. In RO process, as we all know, we can get a permeate when we apply the higher pressure than feed solution. And we can get a brine as a byproduct. In OARO system, the same concentrated solutions are applied to both sides of membrane, and a certain pressure is applied to one side. The same osmotic pressure difference as applied hydraulic pressure can be obtained. Therefore, higher concentration rate than RO membrane is available. So this is the series arrangement of OARO process. OARO process can achieve over 230,000 milligram per liter with one high pressure pump. So the green arrows show the concentration side, which is continue to concentrate, and then we get a final product, brine. And blue arrows are diluted side. They are keep going to dilute it, and then the final diluted solution has a concentration same as the feed solution, so we can recycle it. Let's introduce our reference, the world's first largest scale commercial OARO plant. It is located in Indonesia, Java Island, which northwest side. So it can produce 23,000 cubic meter per day water and 220,000 tons of food grade salt per year. So this plant has been introduced our Toyobo membrane, 10,080 pieces. So this plant is under commissioning now and will start full operation within this year. So let's see the details of the plant. So the intake is around 34,000 cubic meter per day. It's treated by UF and NF. And then the NF permeate goes to SWRO. SWRO and SWRO reject flow goes to OARO system. So OARO system can concentrate 179 gram per liter. So the specific energy consumption from intake to OARO system is 4.5 kilowatt hour per cubic meter. And then the brine goes to MBR and crystallizer. So the whole energy consumption is 9.5 kilowatt hour per cubic meter. So thanks to OARO system, SEC is dramatically reduced. So this is the picture of our plant. So left side is membrane facility and right side is MBR system. So let's see the quick video of our plant. So there are pumps and membranes, and it's very well organized plant, you can see. There's a contour place, and membranes or tanks are there. So I'd like to explain the process design. This plant used the Veolia's NF and RO membranes. NF has two-stage configuration, and permeate of NF goes to RO. And SWRO also has two-stage configuration. So reject flow goes to OARO system. So the key system, OARO process, has 4-stage configuration and 3 trains. Each train have 360 pieces of membrane. So the brine goes to the MBR process. So in preliminary result, we are to concentrate 16.8% and with the 54 bar, which is the less than design pressure. Next, I would like to talk about the energy consumption and carbon dioxide emissions comparison. So ED process can divide the ED process and thermal process. So thermal process emits 0.225 ton CO2 per ton salt, and thermal process emits 0.424 ton CO2 per ton salt. So the total number is 0.649 ton CO2 per ton salt. To compare to ED process, we analyze our plant energy consumption and CO2 emissions. So from intake to OARO system, CO2 emission is 0.091 ton CO2 per ton salt. This number excludes the CO2 to produce water by SWRO. And the thermal process, CO2 emission is 0.183 ton CO2 per ton salt. So the total number is 0.274 ton CO2 per ton salt. This number is less than half of the traditional ED salt process. So this slide shows the comparison of ED and OARO. So left graph shows energy consumption, and right graph shows CO2 emissions. As you can see, replacing the membrane concentration process from ED to aero system will greatly reduce both energy consumption and CO2 emissions. And this plant also reduced the CO2 emissions by thermal process improvement. So this is the conclusion of my presentation. So first, OER process and TOYABOMC's hollow fiber membrane allow brine concentration to nearly saturated concentration using far less energy than conventional thermal and other membrane-based technologies. Second, OER process has been already commercially proven in Indonesia, where salt production and commissioning will be complete in this year. Third, salt production with the OER process will dramatically reduce the CO2 emissions compared to the traditional method using ED. So thank you for attention.
Thank you, Chomi. Coming up is another case study. It's about seawater desalination and related activities in China. Coming up to the stage is the senior water expert at SWEC, Sheng Li.
Good morning, ladies and gentlemen. It's my pleasure to be here. I'm Sheng Li, senior water expert from SWC's Watira. Due to an unexpected issue, Dr. Ran cannot make it here at the last minute and asked me to give this presentation on behalf of him. Before I move to his presentation, I will just briefly introduce what the brine mining activity we have been conducted within Watira. We have developed a comprehensive extraction process to extract, for example, magnesium, sodium chloride, and bromine with one process, and I have demonstrated in the pilot area in Jubel. And for magnesium, we can take a high purity magnesium hydroxide and convert it into metal magnesium, metal for motor car production and missile production. And the sodium chloride we extracted, it has a high purity, more than 99%. Yep, that is what we have been doing in Watira in terms of brine mining. And we are, as my colleague engineer Abdullah mentioned, we are now implementing the whole process in commercial scale in Hako plant. So back to the presentation of Dr. Yuan's. It's about the seawater desalination and related activities such as brine mining happening in China. So I will give a general introduction about his institute first. ISDMU actually stands for Institute Seawater Desalination and Multipurpose Utilization in China. It's established in 1978 and governed by the Ministry of Natural Resources in China. It's the only national research institute dedicated to the seawater desalination and multipurpose utilization. It has 25 professors, more than 300 supporting research staff, and about 200 master and PhD students. The research area within the ISDMU, including like desalination, chemical development like coagulants, antiscalants, and of course then the brine mining, minerals extraction from the brine and the seawater, and also membrane fabrication and anti-corrosion materials, etc. So within those research areas, there are two main practices and undergoing at the moment in their institute. The first one is membrane technology for water treatment. China is the second largest RO membrane producer and also the largest RO membrane consumer in the world according to the 2020 data. With these consumed RO membranes, 4 different areas as the main consumption field, which is the municipal wastewater reuse, and also the industrial wastewater disposal, and the third one is the water pollution control in the rural area, and the fourth one, it would be the seawater desalination. When we talk about the membrane technology for water treatment, then membrane fouling is an unavoidable subject. So that is also one of the main research area within the ISDMU. Along the 30,000 kilometer coastline of China, it covers different water quality zones. So the pretreatment also requires the adjustment to guarantee there is a high quality feed water to go to the downstream SWRO process. By investigating the different seawater region along the coast, they have found that in the eastern and northern coastline area in China, that where the seawater rich in nutrients, they need the coagulation plus DOF plus ultrafiltration to provide high quality feed water for the downstream SWRO stable operation. While for the southern coastline area, coagulation plus sedimentation plus ultrafiltration will be sufficient to maintain a stable downstream SWRO operation. Besides the membrane fouling control by pretreatments, they also investigated the optimize the membrane itself to improve the anti-scaling, anti-fouling properties via surface modification, like by incorporating graphene oxide, amorph, etc. After testing the membrane fabrication formula in the lab, they normally investigate their membrane fabrication formula in industrial scale facility. Below is the facilities they have for this kind of research. That's they use this facility to produce commercial 4-inch and 8-inch membrane for pilot testing. The thin film composite nanomembrane industrial fabrication system they have include the possibility for nanomaterial loading, surface functionalization, deep cross-linking, anti-oxidation, and precision coating technology incorporation. So another big main practice within the ISDMU is the seawater minerals extraction. That's what we call brine mining. In their study, they have already do high purity sodium chloride extraction by doing sequence process. Like the first start, they start with the brine concentration at solar pumps, and then do the clue salt redissolving, and followed by the crystallization, control crystallization. They have constructed a 50,000 ton per year capacity salt production plant, and the product coming out from the plant is also the purity of sodium chloride more than 99%, which is similar as what we have with our material process. And potassium is also another extraction target for them for the fertilizer application. For the potassium, then they have also established 10,000 ton per year production capacity plant. In this plant, potassium chloride is extracted from the middle product called carnallite. The carnallite is a product that they recover or extracted through the cooling crystallization technology. By doing optimization of the crystallization technology itself, they can improve the efficiency. They can reduce the impurity of the content inside of the carnallite, decrease the impurity by 67%, and the final yielding rate of potassium chloride can increase by 10%. Magnesium is also one of the target in their process. They do the magnesium environmental grade magnesium hydroxide and calcium sulfate extraction at the same time by using the brine and lime water. And they have already constructed a 10,000 ton per year capacity magnesium hydroxide extraction plant. But those are the raw magnesium hydroxide extraction from the brine. To further develop magnesium functional material, they need to go through a continuous hydrothermal crystallization process to purify or reshape the magnesium hydroxide they extracted from the brine and seawater. The magnesium hydroxide with the hexagon structure is the one magnesium hydroxide they need for the downstream development of a flame retardant. And bromine also is one of the extraction target for them. They are using the air blow-off technology with chlorine to extract the bromine from the seawater brine. And by conducting computational fluid dynamics simulation, they optimize the tower packing and also the gas-liquid distribution arrangement to improve the efficiency. By doing those optimization at different scale facilities, they can optimize the process of bromine extraction and increase efficiency of 10% and reduce the pressure drop by 15%. In their 1,000 ton per year capacity bromine extraction plant, after doing those optimization, the yielding rate can increase from 75% to 90%. Besides those projects, ISDMU also work together with Tianjin Changlu Hangu Southern Company to construct a comprehensive mineral extraction plant in the northern part of China, exactly in Tianjin. They are taking the brine solution from Beijing power plant and targeting to produce about 4 million tons per year different minerals. Actually, they are targeting for 20 different products with a total output value about 4.7 billion Chinese yuan, which is about 2.5 billion Saudi riyal. And that is the diagram they are planning for the comprehensive utilization of for the mineral and extraction. Some of the pictures of the equipment and process used in this comprehensive extraction process. So currently, the Institute is focusing on finishing the seawater desalination and mineral extraction platform. They have a new research hub or base in Tianjin City, which with an investment of 135 million US dollar, with all these membrane fabrication facility and process pilot testing facilities. As directed by the requirement of Ministry of Natural Resources in China, they are also currently focusing on extracting uranium from the seawater and also the brine. It's a kind of a strategic plan. It doesn't mean it's really economically feasible at the moment, but they just consider it as a technology backup for the future. And they have developed a functional fiber membrane via electrospinning technology for a fast absorption of uranium from the seawater and also seawater brine. Same story for the lithium extraction. They also develop some molecular sheath for the lithium extraction via ion exchange. And they have a one-part demonstration plant of 30 tons per year established in Qingdao, which can concentrate the lithium ions from 0.7 ppm up to 10 gram per liter. What I mentioned that the bromine extraction, the process they used was a air blow-off technology with chlorine. They are also now considering to eliminate the chlorine usage and replace it with an electrodialysis process to improve the process safety. So that's all the presentation from Dr. Yuan. I hope it's clear for you. Thank you very much for your attention.
Thank you, Sheng. It was really interesting to know what are things happening in China and where they have reached so far, so appreciate the efforts. And now I guess it's the perfect time to enjoy a refreshing break, a good coffee break for 15 minutes to connect, to network, to refresh, and then we're going to come back here in 15, so see you soon. جاهز؟ احنا نستناك كلنا. Ladies and gentlemen, welcome back again. Hope you enjoyed your coffee break. Hope you guys got refreshed, connected, and networked enough. But now it's time to continue with our agendas. And before we state the name of our next panel discussion, you know what's been trending the last few days? Artificial intelligence. People are worried. What could it do to our jobs? What could it do to our professions? How could it change the world? And that very question is also valid when it comes to water desalination. That's why our panel discussion is going to be about maximize efficiency and minimize costs in water treatment technology using artificial intelligence and additive manufacturing. I'd like to invite on stage our moderator, the artificial intelligence expert at IBM, Dima Al-Adil.
Okay. Hello, everyone, and thank you for joining us today in the panel discussion. I think the introduction, was exciting enough to know what AI can contribute in the field of water desalination. Just a quick introduction about myself. I'm Dima Al-Adil. I'm an AI specialist. I work for IBM. AI is my bread and butter. I breathe data. I love data. So coming in today, I was really excited with the list of panelists that we have here today, and to have a look on what is the specific, details, the specific risks, the specific, concerns that one would have when it comes to the field of water treatment. Having worked with different fields, different industries, one thing that I've noticed is that usually the risks associated with the use of AI are almost the same. However, there are a little bit of differences when it comes to one field compared to the other. But overall, the risks, the challenges, the fears, the prospects, they are all the same across the world, whatever the project is, whatever the field that we're working on is. What I'm excited about today is that the field of water utilities, water desalination, is that I haven't worked closely on yet. However, in preparation for today's panel discussion, I was really excited when I took a look at the background of each of our panelists and what they bring to the table. And I'm sure that you will enjoy this panel discussion as we delve into the different, the different aspects that goes behind the use of AI in the field. So please, help me welcome our panelists here to the stage in order to kick off this panel. Welcome, everyone. I'm going to give a quick round of introduction of our panelists, and I'm going to ask each of you to give a quick brief about, what your background is and what you're doing. And there is a reason behind that. I was debating whether I should be doing it or asking you to do it, but I'm going to tell you toward the end of the panel why I asked you to do that, because I'm going to hold you all accountable, given what you share with us today. So we'll start with Mr. Mohammed.
Thank you, Dima. My name is Mohammed Anwar, and I'm the Global Business Development Director for Schneider Electric for the smart water solutions and digital transformation in the water business. So I'm leading Schneider Electric strategy when it comes to the digital technology that can be applied in the water segment, in the different sectors of water segments. And of course, desalination process is one of the major sub-segment in the water, or one of the major applications that we focus on, and leverage the maximum of the digital technology on it.
Amazing. Thank you.
Thank you.
Mr. Bora?
Thank you, Dima. My name is Bora Helwaji. I'm working with CMAS Digital Industries as a business development manager for Middle East and Asia for water industry. So I have experience with utilities, energy, and water over 20 years, and working in different fields, commercial roles. My current assignment is digitalization using of AI and helping our customers to achieve operational efficiency. So I'm happy to be with you today. Thank you very much.
Fantastic. Thank you for that. Appreciate it. Dr. Mustafa?
Hello, thank you, Dr. Dima, and thanks for all the panelists to be part of this as well. My name is Mustafa Musa. I am a founder and the CEO of a company called Sedim, one of the companies of King Abdullah University of Science and Technology, and also Aramco. And our job is to make cities smarter, safer, and sustainable through technologies, data, and AI. Our main mandate here is how can we utilize AI in order to save lives, resources in real time. And this is part of what we can discover through this panel as well, and I will share, inshallah.
Thank you, Dr. Mustafa.
No problem.
Dr. Haytham, last but not least.
Thank you. I'm honored and pleased to be here today with you guys. My name is Haytham Hariri. I'm an associate professor at Jazan University doing 3D printing and additive manufacturing technology.
Amazing. So as you can see that today we have a list of panelists who are representing different sectors, whether it's from the private sector, from academia, or, from startups, or, entrepreneurship. So, again, I will come back to that at the end of the panel. However, let's kick it off with a quick explanation. Dr. Hadidi, you have the academic background. You're working at the University of Jizan. Yes. So I think when it comes to explaining stuff, you should be the one who comes easily or naturally to you. Yes. So could you explain to us what additive manufacturing is, and how can it, be, used in the field of water treatment, and what are the benefits of using that in the field?
Okay, thanks. 3D printing or additive manufacturing, we usually call it's a recent technology. Meanwhile, it's not actually recent. It started a couple, more than 30, 35 years ago, but it's a recent technology. The unmatched flexibility of material selection, design, and also scalability of 3D printings have enabled 3D printing to grab the attention for water desalination and water treatment technology. Recently, 3D printing additive being employed and involved heavily and deeply in several sectors, one of which is power sector, and water treatment and desalination is one of which. The way I look at it, I look at 3D printing or additive manufacturing not only in a specific area like membrane, but I look at it from a global perspective. When I look at it from a single component to an assembled utility or plants. So 3D printing has been widely explored for water treatment and desalination. If you look at thermal desalination, we look at how actually additive manufacturing is playing a great role and involved in energy efficiency increase and cost reductions. How to manufacture something like helping the water evaporations, increasing the efficiency and reducing the cost. When I look at the different perspective of it for membrane desalination, I look at how complex the parts can be made using 3D printing. I look at the variety and the unlimited use of different materials as well. So 3D printing enables that we usually say it gives you the freedom of design. That's what additive manufacturing is. You can pretty much design every single component you would like. The other perspective of additive manufacturing, specifically in the desalination technology and applications, is the complexity for free. And not only that, but also give you freedom of design. When we say complexity for free, it means if you increase the complexity of a components, you're only increasing the cost marginally. That's one of the things. One major thing is supply on demand. There is a major issues usually when you have a stock. The stock is another issue. Sometimes you try to have something repaired or fixed, and 3D printing provide you that supply chain demand or supply on demands. These are the benefits coming from additive manufacturing.
That is very informative, given that, you know, I had just a little bit of background on the topic, I think, and I think you have a session later, you know, presenting a use case. So I'm sure that everyone is going to be excited to know more about
My
that.
pleasure.
So thank you, Dr. Haytham. Now, Dr. Mustafa, now moving on to you. In Sadim, I think you use a lot of sensors in the technologies and the solutions that you provide. So how can you, how do you see AI being, utilized in the field to, in order to provide proper monitoring of water plants, water processing plants? So can you give us your perspective on that?
Yeah, absolutely. So from the point of view that you just mentioned, we are providing monitoring solutions, and monitoring here, what you measure, you can basically manage. So we want to provide tools. AI, at the end of the day, is not the target to achieve, is a tool to achieve the means of management and control. That's exactly what we are contributing with. The power of AI, and during also my research years, there are a lot of tools that can enable machine learning algorithms that can enable you to estimate. So in our area of expertise, we would like to monitor a lot of parameters in order to infer through algorithms of AI the water quality and the bacterial content. And that's something that's not available commercially at all in the world right now. Because in order to do so, we need to monitor several parameters, whether it's physical, chemical, and also there is the bacterial aspect, but there isn't anything that is commercially available to do so. That's why AI can come and mine certain gap in order to analyze the behavior between physical and chemical parameters, and from there we can infer what's the bacterial content. And that's very important for water security, for all the organization in the kingdom that provides and supplies water in all of the housings that we live in. So that's basically what we anticipate the role of AI. It's a tool in order to reach our goal of water security and sustainability.
Wow, that is very insightful. So again, it opens our eyes on how deep the process is, when it comes to monitoring the cleanliness of the water and how safe it is to be consumed. Which takes me to another topic, which is a hot topic, I'm sure, in any IT-related discussion or even non-IT-related discussion, which is the topic of sustainability. Bora, this question is to you. And, with sustainability, a lot of the focus on the energy consumption. I mean, given what the gentleman just explained, the processing power behind, the process itself and how the plants are operating, that means there is a huge amount of power that is being consumed on a daily basis by the minute. So what is your view on power consumption, and how can AI be utilized from that matter for environmental awareness?
Correct. That's a very good question, actually, and I think that's the million-dollar question of the day. Everybody's talking about energy consumption, how we can reduce the energy consumption in the plant, and how we can utilize AI. And as rightly Dr. Mustafa said, AI is a tool for us to do certain things. And AI is a very good tool to estimate the process and understanding the specification of the process itself. So with the right modeling, actually we can throw different scenarios to this AI model of any process plant. This can be a desalination plant or any plant in the world. And then we can understand the energy consumption and the output quality that we are trying to achieve. So this is giving us the ability, and with the increasing process power, this simulation can be repeated several times, and AI can try different settings, different parameters during this process, and try to optimize with the target of optimization of energy. They can give us a plan for the existing plant. I think today everybody's discussing with new technologies like new membrane technologies. We are seeing new technologies trying to do revolutionize the water industry and desalination plants. But also we should not forget that we have a huge install base and capacity that we need to utilize efficiently. So we need to look back to our existing plants and find small inefficient points and rectify them. And these are actually adding up on top. And we are having some simulations and studies that's showing you can save only changing parameters and set points based on the AI simulations up to 8% in an existing plant. So 8% seems small, but as an energy-intensive industry, it can be millions of dollars per year. And another aspect of AI is actually everybody's talking about renewable energies to be integrated. This can be utilized on the microgrid fashion. So whenever we have a, let's say, a renewable power close to a desalination plant, actually the renewable power is a little bit different than the traditional power. You need to estimate the production any given time. And AI is a very good tool for that as well, because when you combine the weather forecast together with the, again, the modeling of the renewable power, you can estimate the production of power. And then this estimation can be used backed on the desalination plant, how we can utilize this power, what is the maximum efficiency on this power level. So all these things are actually available technologies and can be already implemented with the existing plants. I'm sure these new technologies will make the breakthrough and we will see more efficient plants, but in the meantime, we should not lose time and use AI for maximum efficiency.
And would you consider that as an easy process to adopt it within plants, or does it usually take time and a huge team? Does it need a huge amount of investment in terms of time and money?
Actually, it is not, because the modeling effort is taking time and money, and this is an engineering effort. But usually, in most of the cases, we don't need any additional hardware. We can do it in some other server or wherever the computation power is, and we can calculate the optimization plan. And this can be even a service to our customers. So whenever we have the modeling of the plant, we can simulate as per the requirement of the customer, and we can give them the optimization plan as an output.
Amazing. Thank you. Now, when it comes to the topic here, which we are focusing on AI, data is very centric to any AI-driven solution. And there is always that fear, just like what was mentioned earlier, that people are always fearing that their jobs are going to be replaced by AI, or that job security, skills, and all of that. All of these questions, are sparked by the moment. However, what I like to call it, usually when I'm talking about AI, I always say don't think of it as artificial intelligence. Think of it as augmented intelligence, because it should be helping you. It should be augmenting your skills. So, Mr. Mohammed, let me ask you about what, given your background, given the projects that you've worked on, given that you're working within the field, how do you see AI-driven data analytics can help the decision-making process for plant managers and plant operators?
When we talk about that concept, I guess one of the things that we need to elaborate first is what are we expecting out of a kind of decision support center in a plant or in even wider range. So when we talk about a decision support, it should be the place where any of the decision makers, and that could be an operator, or it can be a plant manager, or it can be a CFO. So any of the decision makers need to go to a place that can help them to take the right decision on the right time. And that could be quite challenging when we have huge amount of data, because the single human brain cannot process in a short time all these amount of data. So the AI is playing a crucial role in that, because the AI helps in converting that huge amount of data into some information that will help then the decision makers to take the right decision, and of course in the right time, because we would spend 2-3 days to reach to the right decision, but that would be very late if we want to take a faster decision. And that's why we see that the AI plays a big role when it comes to the managing a data-centric, helping the decision makers to take a decision, and the right decision, of course. And if I would refer to just a couple of the use cases that the gentleman has talked about. Yes. So energy efficiency in the plant, and of course bacteria identification in the water. All of these are really very important use cases. Life cycle of the assets, membrane life cycle, chemical dosing. We can list tens of use cases that can be available in the desalination plant. And in order to manage all of that again and provide the decision maker, if we take an example, the operator who is starting in the beginning of his shift, and he wants to operate that plant, and we want to make sure that he operates the plant to the most optimized set points. So we need to enable him. And the AI is one of the tools, very efficient tools, and it has been already explained by the gentleman very well, that we can use it to provide the advices to the operator on what are the most optimized use cases. And if we elevate that to a decision support center that combine other types of data into the analytics, so it will provide more powerful decision support center.
So I see that that's a similar pattern to what I see the use of AI for decision making, across the board in any sector. It's not different,
Yeah.
and no matter what it is, whether it's for education or for water desalination or for, in the medical field, it's always the same use of AI for decision making. Just like you mentioned, it's not just for those who are operating, but for at different levels of, of the organization.
Agreed.
Now, see, apologies for that. Dr. Hadidi, back to you. Again, I know that you have this session later with the use case, but can you give us a glimpse or a teaser about the challenges that you see when it comes to the, additive manufacturing, when it comes to applying it into the field? What are the challenges, and how can these challenges be mitigated?
It's 3D printing or additive manufacturing. It's like any other technology. It has its cons and pros as well. Let me start with just a little bit of opportunities. I'll just mention 2-3 opportunities. Meanwhile, I'll compare it to the challenges that actually additive manufacturing is facing nowadays. The opportunities, especially for water desalination technology and applications, you can apply new materials, a new design. Not only that, but also you can have a novel and hybrid methods using 3D printings. Meanwhile, the challenges nowadays in 3D printing technology overall is the operational and capital cost. That's one of the major challenges actually nowadays the 3D printing are facing. The standardized method and materials. There are no standard method and materials that are being set like any other manufacturing technology. The different manufacturing technologies, the old technologies, they have their own manual standard tables, they have own standard materials, not like 3D printings. From day to another day, you have a challenge of having a new materials and new driven applications. The new driven applications is dictating you that you have to look for a different materials, a different design. One of the very major challenges nowadays, also in 3D printings, not in Saudi Arabia, but I look at it also globally, it's the collaborations. Technologies are there. 3D printing are not reinventing the wheel. It is actually advancing the technology, finding solutions for technology. One of the major challenges for academia and also researchers and private sectors, there's no wide collaborations that are actually dictating the need of these sectors and enabling researchers and people who are actually interested in additive manufacturing to find the proper solutions. That's one of the challenges in additive manufacturing. Thank you.
Thank you, Dr. Hadidi. Now, as I mentioned, when it comes to the use of AI and, as all of my panelists here described and talked about, how it can help in the decision-making, how it can, streamline a process, how it can help us to, increase our efficiency when it comes to, doing our daily jobs, no matter how complicated or how simple it is. However, there are risks associated with heavy reliance on technology, and specifically when it comes to AI. So, Bara, this question is to you. How do you think what do you think the risks are that could be associated with the heavy reliance on AI in the field, and how could that, impact the workforce?
Yeah.
We need to be realistic here.
Yeah, it's a great question. Thank you very much. Actually, as you said, when we say AI, people are getting stressed if I'm going to lose my job or what I'm going to do in the future is the robots going to replace me. These are the things that we are hearing. But actually, it's in the real world, and if we think realistically, we cannot replace people with AI. Because AI is good on certain things that we talked about before, like stimulating, like estimating, like giving you an optimization plan, and finding the right answer from a big bulk data. That is very good, which human cannot do anymore alone. But we should not forget the skill set of the people. When creating AI, also some difficulties we are seeing is that when you use machine learning algorithms, you need some quality data. And when you train the systems with unsupervised learning, sometimes you start to create a black box which is not understood by the people. So our approach is to overcome all these situations and the challenges to create a white box approach, which means that we are starting to model the plant or the process with the first principle formulas, which we know as engineers for many years it's working well. So we connect the dots together to create the plant. And these formulas are, after building the process and the model using machine learning techniques, these are also iterated to the real life conditions. So this accurate modeling also gives the hint to the operator what's going inside, so we can see what formulation is used. Also using the machine learning techniques to overcome, let's say, the accuracy problem. So by this way, we need operators to know the process as they do. Also, they understand what's going on the machine learning algorithm and this white box we are providing. So actually, we need human to be more intelligent together with the machine to work together in harmony to deliver the results. I think without that, it's not possible.
I think you touch on a very important topic here, or a side of it at least, which is the need to empower ourselves with new set of skills in order to be able to adapt to the new technology. So it's not like that AI is going to take over, but we need to embrace it. And just like in the Industrial Revolution, when factories replaced manual labor, that didn't mean that we had to get rid of these employees, but they had to be trained for a new set of skills. And I think that's what you're trying to refer to here. Correct. So while we're still on the topic, Dr. Mustafa, what do you see the prospect of using autonomous or implementing autonomous plants or autonomous technologies within plants? How do you see that fits in terms of what just Mr. Bora shared?
Yes, exactly what Mr. Bora is saying, and you are saying also that we are not going to be replaced by AI, but somebody uses AI can replace us. So we need to embrace it, and we need to equip ourselves with the skills. In power plants or plants that can produce desalinated water or something like this, I'm talking from that perspective. What can we do in order to cope with AI changes and AI tools insertion within the process? For sure, there are many things that are being implemented as we speak in different production units here in the Kingdom of Saudi Arabia, and also working on hand by hand with different organizations, including SWCC. Among them, how can we save a lot of time of sampling and checking the water content in order to process and making sure things are falling with efficiency, and that will result in effectiveness and higher yield for the water that is desalinated. For sure, AI has a lot of, let's say, improvement and additions here that can help out the whole operation from start to end. Even from the start of it, like when we collect the water from the sea, until it goes into the tanks that goes to the National Water Company and be distributed. There is a lot of steps here that can be improved and can be embraced by the people utilizing or operating the whole process. For example, in the sense that we are helping in cities nowadays or power plants nowadays, is that if the monitoring step and the checking the content of the water quality can happen instantaneously utilizing AI algorithm, that can save a lot of time and energy and efforts without going into the lab and checking it for hours or weeks sometimes, or like sending it to another facility. At least AI can shorten the distance and can empower the people to make the right decision and go in the process, and then that will result in higher efficiency, so higher production rate, and a lot of productivity to other entities. So it will impact the whole chain of command. So that's how I see it and how we see it in our company in order to improve utilizing AI.
Well, I mean, I think based on what you just shared, what everyone has shared, as you can see that the impact of the use is not just within our region. It's much more, you know, especially when we're talking about water scarcity, third world countries, the issues of, you know, providing, you know, safe and usable water for those in need. Which takes me to my final remark, and this is why I asked you at the beginning, you know, to introduce yourselves by yourselves, is because I think one of the things that I've noticed throughout my career, you know, jumping from academia to government and now to the private sector, is that there is always that gap. Everyone is trying to serve as a common goal, you know, the bigger goal, but there are always these gaps that need to be filled in order to reach that goal faster. So given that your backgrounds, academia, you know, you came from academia and then you started your company and, you know, with the private sector here with us, how do you see the collaboration? What is the call for action that we can come out of today, you know, in order to, you know, try to call for that collaboration? Let's be practical about it. Thoughts on that, Mr. Mohammed?
I think it's a very, very valid point, Dr. Dima, because every part of the ecosystem has to collaborate together in order to achieve the final goal. And of course, considering the water scarcity that we are seeing in different parts of the world right now, so we need to make sure that we are leveraging the science and the technology together, and we have the right ecosystem that complete that complete solution together. And we cannot split the science where we have the main contents of where we are going to leverage the technology. And in the same time, we need to have the technology capable entities that will be enabled to put in place the right technologies that serve at the end the final objective. Okay. So I see that they have to go hand by hand, everyone who can contribute into that objective.
Absolutely. I'm a strong advocate for that, so I second what you just said. Unfortunately, we're running out of time, and believe me, if you come and approach us, we would be talking for hours about this topic. That's how passionate we are about it, each of us with their, different background. So, I encourage you to approach the panelists, let's continue the conversation. As I said, there is a lot for us to share, but, please help me, to thank our panelists. Let's give them a round of applause. Thank you so much all, and greatly appreciate it. Thank you so much.
Thank you so much, Dima, Mohammed, Bora, Mustafa, and Haytham. What a rich talk. And there are two sides of the story. I mean, like for you folks and individuals working in the sector, now you know that AI is a helping tool which is going to help you be more efficient and take better decisions. As for the bad side of the story, for people like me, probably next conference you will have an AI hologramic MC and I'll be losing my job. Anyways, let's carry on with our agenda. And for our next talk, and before I invite our speaker on stage, there is a story that is worth to be told. See, in December 2022, at Milan, Italy, our next speaker have met His Excellency, the Governor of SWEC and his team. And he shared with them an idea about the world's first 3D printed ceramic membrane, who he claims it will impact the water desalination efficiency. He claims that His Excellency was really interested about it, and him being here with us today, he's fulfilling a promise, not to showcase the idea, yet to showcase a prototype. Ladies and gentlemen, please welcome on stage the Chief Marketing Officer at Evolve, Andrew Walker.
We certainly don't want to lose you to AI, man. Thank you so much for that. Indeed, Your Excellency, ladies and gentlemen, I'm going to use this stage. It's so large. It's begging me to come closer to you a little bit. If I can click forward there. Yes, indeed. We'd like to talk a little bit right now about some cutting-edge technologies. I think it's really important to recognize that desalination has a massive role to play in climate change and combating climate change. We feel climate change where there is water scarcity. And on our travels, we all experience the need for more water and more sustainable water. Desalination plays a big role, but it can't come at the cost of more energy and more carbon footprint. We have to be responsible. And I'm personally delighted that SWEC and the Kingdom of Saudi Arabia stepped forward to be real leaders in the desalination space. Who is better placed to help the world come to greener desalination? Membranes, of course, we've heard a lot about, are at the heart of this transition to greener desalination. But some of the issues with membranes come from the way they are manufactured. If you look under the hood of a traditional polymer membrane, this is what it looks like. You have pore sizes which are quite small, pore sizes which are quite large. They're randomly distributed. Some of them don't go anywhere. They're dead ends. And so it makes it very difficult to have precise filtration. Now, the previous panel, and Dr. Hadidi especially, I can't see you anymore, but thank you very much for setting up the field of additive manufacturing, because that's our specialist area together with materials science. Allow me, if you would, to just show you a picture of how membranes are manufactured. And this is colored in black and white for a reason, because the technologies and the formats of membranes are indeed from the 1960s and 1970s. Not a lot has changed in the way things have been manufactured, not fundamentally at least. If we had a dream when it came to the pore size and the pore distribution of membranes, it might look a little bit like this. If you remember before, we had a random distribution under a microscope. This is what additive manufacturing can add to membranes. Absolute homogeneity, absolute perfection in the way the membrane looks in the microstructures. Now, going back to an analogy which His Excellency and SWEC have used in the past, transforming desalination can feel a little bit like the transformation from candles to electric lights. You know, no one really in the candle making industry foresaw the impact that an electrical light bulb can have. Now today, you would think that an electrical light bulb is self-explanatory. Everybody has it. We flick the switch, or we tell Alexa to turn it on for us, and it's there. We don't even think about it. So my plea is, when it comes to membranes, they should also be self-explanatory. They should just work like an electric light bulb works, efficiently. That's what we should do with membranes. And we're getting there. At Evove, we're a young 30-person company from the north of England, and we have some interesting technologies which I'd like to introduce to you very briefly here in a whirlwind tour. I think it's important not only to have cutting-edge manufacturing and new ways of doing things, but also to respect that there is a tremendous amount of investment in existing infrastructure. And we don't want to throw all that away. We have to enhance it. We have to make it better. That's what we've been talking about. So we have some products to do that, and I'd like to introduce them to you very quickly. They're being used in 5 major sectors around the world, from food and beverage through to ultra-pure water for green hydrogen, into lithium extraction, and of course desalination. So let's go to food and beverage quickly. We did a project with AB InBev, the world's biggest brewer, in one of their breweries in Johannesburg. This is my colleague Tom and Rikus from AB InBev installing the system. And it actually recycles the caustic wash coming off the back of the brewery vessels. It does it with a technology which is really, really important as well for desalination. That's why I'm talking about it. The cost savings for AB InBev, if they implement this technology in all of their breweries, in 1 year is $52 million but it also saves enough energy to provide a small town with energy and the carbon footprint of 200 flights between Jeddah and London. So it can have a good environmental impact, but also save money. For a Coca-Cola subsidiary called Fairlife in the US, we did a project in the dairy produce area and increased the amount of high protein, low sugar products coming from raw milk by 20%. This is all being done by membranes, the same membrane technologies we can use in desalination. Lithium extraction, thank you to Jeff Townsend for the plug a little bit earlier. We have a very advanced direct lithium extraction plant in the UK, which is processing brines, like he mentioned, for example, from Cornish lithium, from Northern lithium in the UK, but also from around the world, North America, Latin America. And it does it very efficiently with ultra-selective nanofiltration membranes at the heart of that. This is the happy customer, Nick Popel, the CEO of Northern Lithium, the first person to pick up battery-grade lithium carbonate from this plant. And we have, just at Evolve, little Evolve, engagement with enough projects just in the lithium sector to be able to fuel 20 million electrical cars every year with the production which we're engaged with, if we were to get every project and if we were to engage and put the technologies in here in every project. Now, the world demand for battery electric vehicles this year is 14 million. So just these projects are enough to be able to provide us with enough lithium for electrical cars. And that's very exciting. I think we can do the same with desalination. There's enough potential to provide everybody with water that is missing water today with the water that they desperately need. So, what are we doing in desal and why is it relevant here? Well, we have some pilots planned and we're really delighted to have signed a memorandum of understanding in Riyadh at the Evolve conference in January. Many of you were there. And also to have the SWEC innovation team come and join us in Manchester in England and see the technologies and our manufacturing facilities, our laboratories in February. So those pilots are ongoing and we're really excited to be deploying some of them. One technology, just to introduce you quickly into it, involves 3D printing. This is a tubular membrane. We use it for pre-treatment, especially with very difficult feeds. When there are hydrocarbons, when there are very high TDS levels, this is a very effective technology. Pre-treatment of reverse osmosis using nanofiltration, existing nanofiltration, we can remove a tremendous amount with the ultra-selective membranes that we have of the magnesium, the calcium, the scalants, and this is some of the data using the feed which we have on the Gulf Coast around Al Jubail. We've analyzed that, we've studied it, we've developed the concept for the pilots. 3D printed spaces, we heard a lot about that, and the grand prize went to aqua membranes. That's fabulous news for the whole area of 3D printing and spaces, and we're really excited as well to be involved in this space. We think, and we'll prove it in the pilot, we can reduce the energy consumption of reverse osmosis by 20% with our 3D printed spaces. They're thinner, we can put more packing density in there, and some of the data we've already measured show that the pressure drop compared to conventional spacer RO membranes, is about half over the membrane itself. Or if you accept the pressure drop, your flux rates can go up by 3.5x. As the brine concentrates through the membrane, you can see the orange curve, you continue with a higher flux rate compared to without our spacers. Going back now, and you were promised a premiere, a world premiere, going back again to this picture and this picture. How do we get to this area? And the answer is with, of course, additive manufacture. And so today, for the first time, I'm very delighted to present a separonic. This is the name we've given for an entirely 3D printed ceramic membrane. And this looks quite small, but believe me, it's very powerful. It's also very heavy. It's dense. And this has the ability, we think, to change desalination. This is how it's manufactured. Thank you, Tarek. Feel the weight.
Very nice.
So this is a prototype, is a microfiltration porosity of 75 nanometers right now. And we're working our way into ultrafiltration, nanofiltration, down to reverse osmosis. We'll get there. And this is how it's made. This is a machine which we made ourselves. We are additive manufacturing experts, and we developed the process to be able to print in ceramic, it's an aluminum oxide basis, without the need for high temperature sintering. So that means you do not introduce the mechanical stresses which are common with ceramics, and you have a much lower cost of manufacture. You don't need to bake it at 1500 degrees C. So it also means, because of the design freedom that Dr. Hadidi talked about, that you can actually print any format of a membrane. Does it have to be 8 inches and 1 meter long or longer? Not necessarily. You can see this animation here of a design we made with a little bit of AI and some supercomputing. And this has a 10x efficiency increase for the flow of the liquid through the membrane compared to an 8-inch spiral wound membrane. So if we can go to formats like this, we have new possibilities and new opportunities. The other thing about ceramic is, of course, it lasts forever, more or less. And so we were speaking to Alexander about subsea. He said we can't go and do anything subsea desalination within 5 years. So as you know, 5 years is sometimes on the limit of traditional membranes in terms of replacing them. Not with a ceramic membrane, that's no problem. The other thing is that there's less waste. You do not have to throw away the membrane, and dealing with polymer membranes around the world and the discharge of spent membranes is quite an issue. Not so with this. It's made with materials that you can actually recycle, aluminum oxide materials, quite easily, turn to powders, crush them. And with additive manufacturing, of course, you are no longer dependent on having centralized manufacturing. And I know there is membrane manufacture in the kingdom from Torre. Imagine if you have 3D printing stations at each of the desalination plants in the kingdom, printing membranes that deal with exactly the right brine. So the membranes for the Red Sea is different from the membranes for the Gulf, for example. The science works. This actually has a precision in the pore size distribution, so the difference between the small pores and the big pores of less than 1% in this first prototype. That means that it's exactly designed for specification. And we no longer talk about microfiltration, ultrafiltration. This has a 75 nanometer molecular weight cutoff. It's absolutely precise. If we want to do a 50, we do a 50. We want to do a 34, we do a 34. Want to do a 0.02, one day soon, we'll do that. So this, ladies and gentlemen, we think is the future. We have a good way to transition with existing technologies, existing infrastructure, and make incremental improvements. But I would argue that 3D printing and this kind of separonic membrane is going to be very important for desalination as we move forward. We look forward to piloting these technologies and are honored to be involved in this journey. These are my contact details. If you would like to reach out to me, I'd be very happy to explain this in more detail. I've got some of our experts involved. Shukran, thank you very much.
Well done, Andrew, and thank you for fulfilling your promise and showcasing the first prototype here at IDD conference. It means a lot to us. Thank you. You know, this is what I like about IDD. Every day we're learning, every day we're seeing experts from all over the world showcasing their studies, showcasing their prototypes, and always trying to find a solution on how to simplify the process of water desalination and reducing the cost. I mean, it is the challenge, right? That's why our next speaker is going to talk to us about highly efficient modeling of transport phenomena for industrial applications and how to simplify it and reduce the cost. Coming to the stage is the Associate Professor of Engineering Science at Oxford University. Ladies and gents, give it up to Professor Budimir Rozic.
Sorry, excuse me. Excuse me, I think it's not presentation. Sorry, just to... I'm not sure if I can talk about it. It's not my presentation.
Okay, so while we find it, give us a little brief, Professor. What are you going to talk to us about?
Okay, so I think I've got it, so we can start now.
Okay.
Okay, so hello everyone. My name is Budimir Rosic, and I do research in the world of fluid dynamics and heat transfer with application to, again, computationally, numerically, and a lot of our work actually has been done in collaboration with different industries, ranging from aerospace, power generation, and energy. And what we always find in communication with the industry, that's what's needed always is, again, improving underlying physics understanding and really developing highly efficient tools that are used for the design. So that's why we hope, that today I'm going to learn more about, again, in these 2 days, to learn more about what's going on in the water technology field and how we can actually help and transfer some of our knowledge to this field. The title of my talk is Highly Efficient Modeling of Transport Phenomena for Industrial Application. By transfer phenomena, we mean heat, fluid flow, heat transfer, and mass transfer, and chemistry. And we all know that they're extremely complex processes, and they're extremely difficult to model, and especially even more difficult to bring those simulations into the design level. Here you have a list of my co-authors, my former students. One of them is Mohammed Al-Makrabi, who is here today. And I would really like to encourage more people, more young, talented people from this part of the world to come and join research that we do. Coming to this event, and this is actually my first conference on water technologies. Being an academic, going always back to fundamentals, and being non-English speaking person, I use dictionary all the time. Just few definitions. If you go to Cambridge Dictionary, what is the meaning of to innovate? The innovate is to introduce changes and new ideas, and I hope we are all going to learn more about this complex concept, I would say, after these 2 days. Next one comes to the list is novelty. And so what's the novelty? By the definition, novelty is quality of being new and unusual. Translating to something that I work with is like, for example, buying digital twin, virtual reality-based software systems that you obtain, but actually you don't know what you do with it once you're obtaining it, and actually you don't know what's the extra value that you get from them. And there is a fashion. Okay, fashion is a style. is a style that is popular at a particular time, especially in clothes, hair, makeups, etc. And I would say it really applies to, in many ways, to corporate world and even in academia. I guess you can see that, just like people just following trend. And then again, in the same light, like following this science, actually I'm continuing now the main body of my presentation. So I guess we've learned and we've heard a lot about, and I think it's never enough because of the scale of the problem that we are facing. It is never enough. So we've learned a lot about this unprecedented global challenges that we are going through, caused by climate change impact and the energy transition that we have to go through. So, and also, I always really try to see as opportunities, and many people pointed out that the opportunity there. And why I'm personally positive that this can happen, this can be delivered, is because simply we have capabilities, we have capacity, and the most importantly, we have tools. Our engineers now have tools to develop this. 20 years ago, if you ask me the same questions, I would say no, maybe no. I would be much less optimistic. And again, as I said, all industries, these are just some industry related to, again, fluid dynamics, need to accelerate their design, improve efficiency and operations, and at the end, innovate. Okay. So who does innovate? And again, if you think about innovation, I guess to many, first person that comes across the mind is Nikola Tesla, one of the biggest, actually, innovators of the 20th century, and very famous for his discoveries in the field of electricity and electrical engineering. But less of you are familiar with the fact that he worked for almost 25 years in mechanical engineering. And actually, most of his career, he worked in trying to optimize and design new fluid devices like pumps, turbines, and valves. And again, so the question is why such a bright mind was successful in one area but was completely unsuccessful in the other area. Although even today, many academics and researchers, engineers, are trying to actually revive some of his ideas, and then every so on you see PhD thesis coming from a university where students investigating actually performance of some of his concepts. The answer is simple. He didn't understand physics. Physics of fluid mechanics was just not mature enough. So the field wasn't mature enough. And second thing, he was a loner. He didn't communicate. If he was communicating with somebody else, he would possibly be more successful with his intuition. And the last thing is he didn't have tools. He didn't have tools to actually explore design space and actually test some of his ideas. And I think that's different. Our field has evolved a lot. We've learned a lot about fluid dynamics, although this is one of the most difficult problems in nature, and many of you are familiar with the fact that Clay Maths Institute, that sets this so-called millennium problems, identified existence and smoothness of Navier-Stokes equations as one of the 7 most important problems in mathematics. So it's a very complex, and then again, we really always have to be fair to our engineers and you're designing when some designs don't work as well as we expected. Physics of fluid dynamics is extremely complicated. And then again, so you can see, as I said, we have progressed a lot, and there is, especially in the last 20, 30 years, there is a lot of progress, especially in computing power. And then we were actually, and even now, traditionally, the advances in modeling of fluid flow by computational fluid dynamics have been benchmarked by high-fidelity simulations capabilities. So we have high-performance computing. They're parallelized. We use multi-core CPUs, GPUs, LES and DNS simulations when we are actually resolving some of these, like turbulence scales. Actually, we're talking about multi-billion numerical mesh size with if you want to do post-processing is probably of a capacity of 250 terabytes. Okay, so for a single simulation of high Reynolds number, when you just want to resolve all turbulent structures. So as we increase, I guess, the resolution, if you're resolving more and more of these turbulent structures, the computing power just goes through the roof. And again, so that where are these high-fidelity simulations are actually used. They still have their purpose in industry. They're usually, I would say, still one-off simulations, and then they're used really to understand the physical, improve our physical understanding of flow phenomena, complex flow interactions, which is very, very, very useful. And at the same time, improve and calibrate design tools. You've used them more and more, these high-fidelity simulations, to improve low-fidelity runs-based turbulence models to accelerate the design. And again, it's used to demonstrate the technology and technology readiness level. Sometimes so it's very, very nice to see simulation like this that illustrates many, many capabilities that a company would have. So what are the new requirements and potential solutions? So we have to, this is acceleration. New requirements are on the acceleration of design process, optimization, and potentially innovation, and testing at the end, that, trying to replace as much as possible complex physical testing. We have process and system monitoring. We would like to exploit opportunities brought by digital twins. Also, we always permanently want to improve the energy efficiency of our system or component individually. We want to explore and exploit possibilities of remote sensing and monitoring of components and identifying life penalty and so on. And then in parallel, what we have today are opportunities brought by machine learning, and we've learned and heard a lot about this today, and additive manufacturing. Again, a colleague just before me was talking about some very interesting, very exciting application of additive manufacturing in these technologies. And again, as you see, the nature of the field of desalination, meaning we're dealing with very complex geometries in heat exchangers, in membranes, filters. So how do we deal with complex geometry and how to model them quickly, how to model fluid flow with such a complex environment. So the three keywords I identified is acceleration, accuracy, and real time. Okay, and so how to achieve that? We have to throw tools that we sort of already have around us, but in somehow we are reluctant to use reduced order model, for example, because sort of we've learned their limits and we know that they are not that accurate, actually. But there are ways how you can actually combine tools of different fidelity, even combine physical measurements with tools of different fidelity, and you can get suddenly highly improved, high accurate result in real time that then you can use for all these different applications. And then that's what I'm going to talk about. This. Through 4 examples that I've selected, 4 examples show 4 different casings and 4 different situations that we want to show. One of them is a hybrid plant monitoring methodology on the example of thermal power plants, how we are solving in real time, this time, very complex thermofluids fields. But you can think that this methodology can be universally applied to any complex system that involves complex physics and involves physical measurements and simulations. So the second one is, again, following on additive manufacturing. We are trying to demystify additive manufacturing from the point of view how we can actually use additive manufacturing on the design level. As you can see, again, for many applications, there's usually one-off simulations, one-off optimization, you get one-off geometry. But you don't have full control over the whole design, or actually it's very difficult to put additive manufactured component in the design process. We just don't have control over that, and that's what we engineers, we don't like that. And actually, this is actually literally breaking our contract with society. We can't predict, all aspects of our project. We're losing control in some way, so the trust of society is not there anymore. So we're trying to bridge that and how to really properly introduce additive manufacturing into the design process. And then again, after that, I'll just briefly talk about how we deal with this, how we model fluid flow within such complex structures. Structures like if you have compact heat exchangers, if you have membranes, porous materials, if you want just to throw computing power at that, you can say, oh, we are now using, supercomputer. This is so easy, again, so every institution, every company, university has really very high actually capacity, and so all these one-off simulations are again possible. But if you want to deploy additive manufacturing, any more complex design optimization method, you're struggling. We are struggling because the speed is just not enough, it's just not there. So I'm going to show in one simple example how we bridge that. It's again clever way how you bring some bit of reduced order. Again, tools that we already have. and we already are familiar, even our young students are familiar with. And then we can actually get almost a step change in computing power that we have. And the last one is going to be an example of how we link quickly complex chemistry, which is on its own very, very difficult to solve, and aerodynamics. How actually, we know that actually if you want to model complex chemistry, you deal with, sometimes with thousands of secondary reactions that is in some way, in many applications, they have to be included into the simulations. How we deal with that? So you can see, it's all about how to bring the complex physics, complex simulations to the level that it can be used in engineering for many different applications. So the first topic is this hybrid plant monitoring methodology. As I said, it's a universal methodology. Yeah, I'm just showing an example of a thermal power plant, but it can equally use to any system, any dynamic system that has multi-physics and also relies on physical measurements and computational and numerical simulation. But what's the underlying message here? It's really how to manage. It's the management of available digital assets. So the digital assets that every company would have, and that usually after that one task that we use that asset for is completely, that asset stays somewhere on the side until we repeat the simulation. We want to try to bring all these different assets of limited accuracy and how we can use them to improve the speed. Okay, as I said, the example here is it's a flexible operation of power plants. When we have conventional power plants operating with renewables, again, they face uncertainty and a much more frequent period of stops and starts, actually, that we have. So what's the crucial there for this technology? The crucial is to how accurately we can determine thermal stresses of the turbine, together with thermal field, thermal stresses, and clearances in order to make the decision that we can run turbine at a particular moment, because that makes profit, or actually if one wrong run can half life of turbine that costs probably $100 million. So how to do this in real time? So if you do this, just by measurements, you can see you can put instrument your turbine in your system with X number of sensors, but sensors don't give you enough. They're accurate, of course, if you don't have fault readings. Sensors are accurate, but you just don't have enough spatial resolution to actually, so that you can reconstruct your problem. If you do high fidelity simulation based on finite element or some conjugate heat transfer, then you have to deploy a high fidelity CFD to model the fluid flow, and you want to couple solid and fluid. It is extremely difficult. And again, it's one of those, again, you use supercomputer to do this one off, and you have student doing masters, at least student to do this. It's just out of the question that you can do something like that. But at the same time, there are other tools like a thermal network model. So if any of you has taken first course on heat transfer, learn thermal network model, which is actually analogy between, and that's how we teach students, analogy between conduction to analogy between electrical circuits and heat transfers. It's a very simple model and very fast. Actually, you lose a bit of accuracy, but it's fast. You can run in a second, and that's actually, so if you deploy that, you have somewhere on the side high fidelity CFD or simulation. You can use all the time, but you can perform one or two simulations, and then you'll be able to store this data in a clever way, and then deploy reduced order plus experiments, and then you can get into real-time prediction. So the system is not that easy. Again, you can see the whole the framework is rather complicated. It integrates all these physical measurements, hybrid tool, low and high fidelity tools through an encoder at the same time. So we use also in a very clever way machine learning. What's machine learning for us? It's we engineers finally have got a tool that we can actually use to very quickly to compress and decompress data. So it's very powerful. This is something that we didn't have before. But we still, this process anchored with physics, we are not using that as a black box. And that's always the key thing. So it's a very complex system, but it's really based on the tools that every engineer would be familiar with. And in that case, so you can see, we start with this, so you can see on the left, on the top left picture, you have this, these are 64 sensors that are placed around this turbine. And from there, we use so-called Delaunay optimization to reconstruct, and there are some other tricks. Again, I'm just simplifying this, how to reconstruct this actually sparse measurements and then reconstruct to get 3D image of this turbine. So once we do that, actually, through this, establish the methodology, then we deploy autoencoder. Then we employ autoencoder to try to reconstruct, actually, and then how automatically, from the set of these experiments, measurements data, we have 64 measurement points over 500 days, and then we can actually train autoencoder and then actually be able to reconstruct the thermal flow field. So, but what's the key here now? To train the latent space, we use latent space for all these different applications. So we train the latent space multiple times. So we use, for example, thermal network model, perform the simulations, and then use that to reconstruct actually reconstruct the field again, high fidelity temperature field at the top, and then use the same common space, latent common space, to actually to get it through get a low fidelity to low fidelity temperature prediction, and then we can use the same latent space to go from the low fidelity temperature that we have through measurements, that we can quickly, and the Delaunay optimization can quickly get high temperature reconstruction of that. So you have very limited number of sensors, and we are able now to reconstruct that on the surface. So now that's a key thing. Why? Because we are using this high fidelity surface temperature distribution to anchor all our numerical simulations. So we are anchoring reduced order system in order to, so we can actually even in the region where we don't have heat transfer coefficient, for example, we are able to reconstruct what's the value of heat transfer coefficient there to give you this temperature prediction. So we're getting very, very now accurate. We are getting very accurate representation of the thermal system with very, very reduced order numerical method and few physical measurements. You can go a step further in every experiment when you're designing. As I said, this system could be applied to any experiment. How to you design it, where do you place actually physical sensors in your system. So we're using a similar tool, again, that includes this high fidelity, low fidelity transfer of data. You can see that you create this map of user control mask with in this case 500 thermocouples, and then we go through the autoencoder with the same latent space that we have that describes this system. So it's almost like a physics-informed system, and we get that's the distribution, sparse input, that's the distribution of sensor. That's how sensor should be placed in order if you want to get good reconstruction of the thermal field. And this is effectively something that you have to perform when you do any type of experiment. You need to perform this. And then, so if you manage in that case to reduce significantly the number of sensors that you use to measure the temperature field. And then again, we are combining now, as I said, physical measurements, reduced order model, which is thermal network model. It's very simple, very fast. And in the background somewhere we have, to the right, we have this high fidelity CFD. This is high fidelity simulation that is done one-off, not used in the design process, but we use this few simulation to reconstruct information that we need. One of the most important things when you talk about the multi-fidelity simulation, multi-fidelity transfer of data, is the speed. We always think about simulation, when we think about numerical simulations, we think about the running time of each simulation. But if you have a multi-fidelity, if you want to transfer data from one simulation to another, doing interpolation actually is much, much more computationally demanding than simulation itself. So if you want to get something in real time, so dealing with this multi-fidelity data, moving them through different level of fidelity is actually very, 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 very important and very, very tricky. So at the end, you get something that looks like this, and then you get very, very accurate in real time. This is over several days prediction, and now the system can be actually used. It's the first of its kind, actually. We checked with all our partners from Japan, Europe, and United States. We think that this is a unique, actually, capability now that you can do this in power generation. And you can see locally at certain locations, we are able to predict this data. I will skip these slides, and then again, so just few words on additive manufacturing and actually how we are demystifying what's the additive manufacturing about. So again, so it gives us actually now this AM and computing optimization. You never think about additive manufacturing. You have to think about computing optimization, computing power that enables that. And then in that case, you have possibility to create really complex internal geometries, okay? And then within any design envelope. Now that's fine. But you can see in this picture you have geometries that are really result of, the optimization is really driven by design's experience. So this is something we can imagine. But we can go beyond that. With the topology optimization, we can actually create now structures that are, again, beyond what we can actually imagine. And again, one of the first topics is actually density-based topology optimization, in which, again, you specify the fixed number of, let's say, finite element points, and then you get this structure that actually is very, very superior compared. It has very high performance. But what's the problem with this? Again, forget about manufacturability and then difficulty to model. First thing is that in this case of density-based topology optimization, you don't have, again, control over the design. You can get, by changing just numerical points, you will get different solutions. And that's absolutely what we engineers don't like. So we cannot control the design process. So what we are proposing triple periodic minimal surface structures that are mathematically defined structures that can be parameterized here. And they're very simple, okay? So you can see that they can actually, by using the core form, by using of Fourier series, it can be transformed to set level equations, and then you get very simple, this is in the red box, you have very simple set of equations, but it's now parameterized. And phi is what we call set level ISO values. So by controlling that ISO value, you can see you get different shapes, and there are many of these structures that you can use in play. What's the key with these structures? Again, they have very elegant maths within, and actually, many of them, they've been found in nature. Actually, gyroid structure actually is found in the wing of butterflies. Diamond structure is found in shells. And then, but what's the key thing? You can create heat exchanger now that can be additively manufactured or mass exchanger in almost no time. By setting this ISO value to positive or negative, you can grow cold side and hot side of heat exchanger, and then in that case, distance between these two surfaces is actually the thickness of that. And if you can put this in any envelope now, we can define any envelope and use distance field representation, combining with ISO set level equations. We can immediately, in no time, this is all streamlined, you can pack the heat exchanger. You can change ball density, share of each domain, elongate cell size, increase the cell size. But what's also important for additively manufactured surfaces? Manifold. Manifold very often in conventional heat exchangers occupies about 30%, up to 30% of the overall volume. Additive manufacturing, especially these EPMS surfaces, allow you almost ideal mixing with no space, that you can actually now, manifolds actually can be integrated directly into the structure, and that at any point, because you can do this so-called graded manifold feature, and then you can place manifolds at any location. So you have completely freedom of operation, but it still is controllable. Every parameter that we use is controllable. And then again, you go a level beyond that, and we think it's quite unique. Again, bringing this to the level of what can be done is actually, would be like a conventional, what other people are doing. You just place this, functions, analytically defined functions, and then what we are doing now, we are in the given envelope, we are defining now ideal flow, where actually the first see where the fluid would like to go. And we use that to define natural coordinate systems, and then take this natural coordinate system to get naturally grown actually structures in the direction where we want. And then on top of that, we also develop our own mathematical functions that are flow friendly and actually based on the entropy generation, mixing mechanisms, boundary layer losses, and in that case you can actually get into the system that can be now used actually for all these different applications. Not on a micro scale, because we can actually transform power plants in this sense, but just changing, not the manifolds. We can change instead that you put in the manifolds to control losses. You can change the manifolds, and in that case you can really save megawatts of power just by modifying these things. At the same time, the main limitation is still cost. It's very expensive. Limitations is building envelopes. Still, we can print only small parts. Surface roughness is a killer, actually, if you want to do modeling of these structures, because you don't have control. So there is a big difference between what you model and when you make this between in the performance. And again, at the end, computationally feasible simulation. So you still don't have computationally feasible simulation. So just please forgive me. I think I was told that I'm going to have 20 minutes. I'm looking for a person who promised to give me this 20 minutes. So it's like, I'm just going to finish very quickly. How do we actually go along this line, and then how we can actually improve computing power? How we bring computing power down to something that can be used as a regular design process? It's very simple. So it can be used actually for all this porous material, membranes, complex structures. So this is what we do. This is very elegant, very simple. Again, student can do this. What we're doing, we are actually in the complex geometry. It has these steps. We have coarse mesh, coarse computational mesh, and then we add on top of that, we add a certain location, we scan the fluid, and we get identify regions, repeating structures, and there we specify fine blocks, which we call numerical probes. And then for these numerical probes, we get solutions, and then we define actually source terms that we scale by using POD, proper orthogonal decomposition. So you can see now in this case, you get 60 times 4 in this case. So that this is top and bottom is fine solution. This is coarse solution. You get 64 times coarser mesh actually that gives you quality of the solution that is equal to the original high fidelity. So you can accelerate things up to two order of magnitude for that. And the last thing, I'm not going to go to that. We've been talking about innovation. We've been working with a Finnish company where we actually accelerated and changed completely how we actually crack the oil actually for olefin productions. Replace these large furnace radiant sections that heats naphtha and steam at 900 degrees. We've done this by replacing all this with a small turbo machines. So we have managed to achieve 500 times reduction in volume and then achieve in this high yield in the process compared to conventional technology, 70 years old technology. For that we needed chemistry. This is a turbo machine. Now this can be used for all these different processes: hydrogen production, steel production, hydrocarbon cracking process, cement production, plastic recycling. And again, so this is actually really innovation that came from actually completely different things. So it's innovation in chemical industry that came from turbo machinery aerodynamics. And for this you need chemistry. To get the chemistry is very complex, and again we do this again by reducing this to the system of again autoencoder. We use reduced order. We use reduced order models to create training data, and then only with acceleration of about 30%, up to 3 times, we can get actually very fast simulations of these very complex processes. Okay, so sorry, this is end of my presentation. Sorry for taking 5 to 10 minutes of your lunchtime. So I think I gave you very quickly, and then this like a illustration of very complex physics of transfer flow phenomena that require high computational cost. And then we think that actually this hybridization of all these different tools, high fidelity, low fidelity, can significantly accelerate these processes. And that finally we can actually, there are tools, there are ways how to bring actually these simulations of this complex flow phenomena, how to bring them to the design level to help at the end the designer. Thank you very much.
Thank you, Professor Rosic. We appreciate the presentation and the efforts. And now I'm going to go off script and off agenda, to be honest. And this is something probably unique for the first time happening at IDD conferences. I'm not going to be the person who's going to tell you what's going to happen right now yet. I'd like to invite on stage His Excellency's Deputy for Innovation and Research, Engineer Tariq Al-Ghafari. Now, going off agenda, that means you have a big announcement. I don't know what it is, but here you go.
Thank you, Mohamed. Okay, hello everyone. I think one of the things I was eager to tell you today is the announcement that we heard from Evolve. I think in such a conference, when people come and they display this in such an event, I think we believe in this technology, And for that, I would like to make a commitment so people can, even for next year, can consider displaying their technology for the first time. So our commitment for Evolve is basically to take this journey with them and to take the piloting for it underneath all the circumstances. So thank you, Andrew. Thank you for your time, and thank you for showing this to us. Thank you. And not only that, what I would like maybe, I will give the chance for 1 minute for the audience. If anyone has any thought, whether in the people who are in the desalination industry or off desalination industry, to tell us about what they thought on the technology that was displayed by Evolve. We have 1 minute. Okay. We have 2 people, Abdullah. So if you can state your name and where you are from.
Hello, everyone. My name is Abdul Jamela. I'm a process engineer in the pulp and paper industry. And I was very impressed with all the mechanical developments towards water desalination, but also really impressed with the AI developments and computational work that's been going on. So I'm very excited for what's going on in the industry and excited to see what the future holds.
Thank you, Abdul Hadi. And then we have another person here who would like to share his thought as well. Thank you, Andrew, for giving us the chance and explaining to everyone what you have done as Evolve.
The mic is coming. Just 1 minute.
So now when we are seeing, for example, computing flow dynamic simulations, and then we are seeing 3D printing, we can see how both technologies can merge, because with these technologies, we can predict and modulate which is the best structure and the best design that allows you to provide less pressure drop, better efficiency. You can modulate in the computing fluid dynamics simulation software and then construct and then try and construct. So this is impressive because then you are moving from digitalization to real test and then move forward. And this is the thing that will allow us to design and develop new technologies like ceramic membranes that will allow us to dramatically advance and improve performance of this kind of technologies.
Thank you. Thank you so much. Thank you, Andrew.
Thank you. Now, I'd just like to express my appreciation for convening all of us here. With so much knowledge in the room, we cannot be anything but successful. Thank you.
Thank you. Thank you, man.
Well, what do you know? I just witnessed Andrew Walker becoming a billionaire. Good for you, Andrew. Good job. And now we're going to take just 5 more minutes of your time. We're going to add up some more time for the lunch break. But now we'd just like to have to do a small thanks to all of our keynote speakers. I would like to call the names on stage, and Engineer Tariq, His Excellency's deputy, is going to show a little small piece of appreciation. So I'm going to be calling the names quickly. If you hear your name, kindly join us on stage. Let's start with Professor Tony Conway. All right, Tony is here. And Dr. Fahad Suleiman. Dr. Diraj Bardwaj. You guys are going to clap a lot, by the way. I don't want to keep you tiring. But we can do a one big round of applause at the end. Alejandro, give me 1 minute. Alejandro Storniolo. I know I got it right. Dr. Mu'taz Slaim. Gonzalo de la Camara. Walid Hassan. Jerry O'Toole, Carlo Zaffaroni, Sarper Sarp, Shane Allen Schneider, Harvey Winters, Ines Kim, Domingo Zarzo, Carl Ganter, Seong-Gwon Im, Faisal Al-Umar, Graham Bateman, Rahul Nair, Hussein Basi, Tariq Ahmed, C. Jong Yong, Benjamin Renke, John Tonner, Kim Chon, Yang Gwok Yu, Jason Neo, Jeff Townsend, the cool guy Benjamin Tam. You know you're the cool guy, without a doubt. Dennis Gibson, or Gibson. Nick Hankins. Alexander Fugelsang. Chomi Han. That's a lot of people on stage, a lot of experts, a lot of knowledge. How lucky I am. Ruan Goling, Deem Al Adil, the AI expert who's going to make me lose my job at some point. Muhammad Anwar Ibrahim, Bora Hilvachi or Hilvaki, Mustafa Musa, Haytham Hadidi, the billionaire Andrew Walker, Budimir Ruzic, Neil Reynolds. Can we put the music a little bit higher? You know, let's hype up the vibe a bit. نرفع الصوت يا اخوان في الكنترول الموسيقى بس. The lovely Avent Busy Dinhoot. I got it right? عبد المجيد العمراني, مازن القرني, مريم عودة, كريم حبايب, and last but not least, Christine Cliffner. I'm okay with 30%. I'm good with that. Okay. If any of the speakers that I've accidentally missed mentioning their name, please join us on stage so I can mention your name. And Senor Leonardo Cortade from Mexico. And also Mu'tasim Abu Sha'ban. And Eva Gonzalez. I mean, this is the least of appreciation that IDD is giving to our speakers, to our experts, to our scientists. They have done a lot. They served the science. They've served the sector. We're definitely honored having them here with us. And as we are saying, this is the least that we could offer. And also Song Hoon Rio. Sorry. عبد الله الجابري وناصر العدواني. Please join us on stage as well. And last but not least, the second coolest guy in this event, your MC, myself, Muhannad. Thank you so much for your time, ladies and gents. Thank you for sharing this appreciation moment with us. Now we're going to enjoy our lunch break. Supposedly we should be back by 1, but we'll be back by 1:15 to give you enough time to refresh, network, connect, and have some food. So we'll see you soon. Okay. Hope you enjoyed your lunch break and got the chance to refresh, network, and connect. Because right now we're gonna kick off again with our agenda after this lunch break. And we're gonna start with a very special keynote speaker. But before I introduce him, you know that we're talking about innovation. And imagine if a lot of people manage to collaborate together to make that innovation happen. Obviously, it needs a special environment to make it successful. Therefore, our next keynote speech is going to be about collaboration and innovation. I'm delighted to invite on stage the chair of the UK Water Industry Forum. Please give it up to Tony Conway.
Good afternoon, everybody. I'm so pleased to be able to contribute to this conference, this excellent conference. So well done to all those people who put it together. A really, really first-class job. This is my first opportunity to visit Saudi Arabia. Lovely people, lovely place, and I've been made to feel very welcome. So thank you very much. By way of background, I'm a former executive director of a UK water utility, United Utilities, that serves 7 million people. Whilst I was at United Utilities, I had a fantastic title of Director of Curiosity. It gave me the opportunity to look for world-leading innovation all around the world. I'm now a professor at the University of Sheffield with a research focus on how to accelerate innovation, how to make it happen quickly, and what the water utility of the future looks like. And I've got a particular interest in collaborative innovation, and that's the focus of my talk for today. And indeed, that focus on collaborative innovation has been a recurring theme throughout many of the workshop sessions. So this is an iconic reservoir in the northwest of England. When I look at this picture, the world feels good. All is calm. Everything is still and nothing is changing. If this picture kind of represented our industry, in my view, it would be totally wrong. Because I think everything is changing and nothing is still. In my over 30 years of experience in the water sector, I don't think I've ever seen a time of such dramatic change, exciting change. There are challenges to be addressed. There's climate change, there's carbon, there's resilience, there's sustainability, there's emerging contaminants, there's rising customer expectations, there's how people value water. And actually, alongside challenges, there are opportunities, huge opportunities, exploiting digital thinking, making best use of artificial intelligence, and a lot more. So this array of challenges and opportunities demands that we think differently, demands that we innovate. And actually, there isn't a monopoly on wisdom. If you think about bringing any change into the water sector, it involves so many dimensions. So to bring about change, to innovate, we need to bring expertise together. We need to bring together the best thinkers in a joined-up way, working together and essentially collaborating. So successful innovation demands collaboration. Now, I was privileged to chair a research program known as the 2065 Water Research Program. It was called 2065 because we were looking to the future. It was a consortium of 6 leading UK universities, but actually far more important than the universities was this ecosystem this family of relationships which we brought together. We brought together a community, an ecosystem of water utilities, of supply chain organizations, of regulators, of digital specialists, all interested in a common cause of moving our sector further forward faster. And having that group, which were all focused on the same thing, was just so exciting and fulfilling. And we created thought leadership clubs around key topics. And we tried to work out what were the 8 key topics we could focus on that could help us move forward faster, just as far as we could. And one of those key themes was collaborative innovation. We recognized that to make a difference, to innovate, people need to work together. So how can we work even better together? How can we collaborate better? Because collaboration doesn't happen by accident. It requires purposeful intent. It is skillful. It is a discipline in itself. So, as I said, one of our 8 research themes was all about collaborative innovation. And our aim was to understand the factors that can help or hinder organizations and people working together. And as well as writing academic papers, and we wrote a lot of very well-received academic papers, put together a user-friendly, industry-facing guide that people could adopt and make a difference to collaborate better. And we published that guide, and you can see a picture of it on the right, and you can download it. And in that guide, we describe our research findings. So to organize all of this, you need to have a mental framework for thinking. So we took our research evidence, which we collected over 5 years, and we created 6 project stages. And things do overlap, and not every, and you have to be kind of flexible in this stuff, but you need to start somewhere. So we created 6 key project stages for collaborative innovation. The evidence that we found clustered into 14 key themes, and within that, there were 44 key factors that could help or hinder collaborative innovation. So in the guide, we describe these, and we describe these in a user-friendly way with examples, and we talk about how to be really good at creating a vision, how to be really good at creating an environment where people feel comfortable and want to contribute, how to be really good at handling intellectual property. So it covers a vast range of things. And I'm not going to take you through all 44 factors because you can download the guide and see those, but I thought I'd just talk about a few. A recurring theme across all of our research in collaborative innovation is building trust across the team. Innovation never happens in a straight line. And when you have partners working together, the actions of one partner, or the findings of one partner, or the contribution of one partner has a bearing on the next step, on the next partner. So combining expertise requires trust. And I described in this slide as trust is the fuel which powers the journey. And I've just pulled out a few of the factors relating to trust. At the left-hand end there, the co-creation of the innovation goal. People work together, collaborate together for a purpose. Each organization, each person has a reason why they want to work together. So understanding not only your own reason for working together, but everybody else's is absolutely key. And if everybody understands what each party wants to get out of the collaboration, you can create an innovation goal, a project goal, that motivates, that stimulates. Creating an environment where the team feel comfortable to speak out. We've all been in meetings, I guess, where what we're thinking isn't necessarily what we are saying. And that can be because we can be afraid that if we voice a particular opinion, it's not going to go down well. Overwhelmingly, the most successful collaborations that we saw are in those circumstances where an environment, a culture is developed where it's fine to say what you think. Not fall out, not be disrespectful, but to say what you think. And quite often, those conversations can lead the team into a better place. The role of the leader, the style of the leadership, absolutely fundamental. You can feel comfortable, you can feel motivated, or you can feel left out. Again, I go back to the point that collaboration is a skill. It requires purposeful intent and focus. It doesn't happen by accident. So often in the evidence, we found that the end users of innovation weren't involved in the front-end thinking. So when the innovation was developed, the operational end users would be thinking, what's this? I didn't want this. This isn't going to work practically. So trust involves engaging the end users at the start. Valuing diversity of thought. Innovation involves clever people with expertise who are helping the team step into a new place, a new place overall. So being welcoming of different opinions, diversity of thought, is the only way that innovation can happen. Part of encouraging that diversity of thought and expressing that thought is creating an environment where power imbalances don't distort discussion. You can sometimes get a very large, powerful organization working with a very small startup, agile innovator who's just got a disruptive way of thinking. If you don't manage the surroundings to enable those conversations and to make sure power imbalances don't distort a discussion, there's lots of evidence that value is lost. I could take you through all 44 items, but that's just a kind of a taste for it. What I would say, when you download our guide, you'll see at the back of it, and I should say, it is not an academic paper. I'm from industry. It's an industry-facing tool that can be picked up and used. We include in the guide a diagnostic questionnaire. And it's just got a really simple, straightforward set of questions. It's grouped into project stages, themes and factors, and you will see that you'll see our 14 factors there, from clarity of purpose, sponsorship and leadership, partner benefits, cultural dynamic, how you handle risk and failure. Our evidence led us to clustering those as 14 key themes. And then for each of those key themes, we've got underpinning factors, and we've got really simple questions where participants can score how the team is doing against those factors. I'm just stressing, it's very, very usable. And then you can draw this chart where you can signpost how that team is performing from a collaborative skillfulness point of view, where it's strong, where it's doing okay, and where there are weaknesses. And I would always use our guide. I wouldn't start at the front end and read it to the back end. I would always use our guide by starting off with a diagnostic questionnaire. That will signpost the areas where there is weakness. You can then look at the relevant factors in the guide, and if you look under a particular factor, it will describe this is what good looks like, and it does it in a very brief, accessible way. And here are some how-to steps to increase capability against these areas where there are weakness. So always start with the questionnaire. By way of a case study, United Utilities are using the guide, as are a wide number of organisations in the UK, to build their collaborative capability and to help their projects go more smoothly. So again, you can find this case study online. The key messages to take away from it is that what you have done, United Utilities, they score the questionnaire every 2 months. It might be scored by individuals, it might be scored by partnering organizations, but everybody scores it. Those scores are then brought together. And you can come up with an overall view of how the project is doing from a collaborative capability point of view. And you can also look at how individual organizations or people are feeling about the collaboration. And the feedback from UU, what they do is score it every 2 months, dedicate some time at their next project progress meeting to review the scores openly and honestly, because they've created an atmosphere where people feel very comfortable saying what they think. And it leads to some very useful adult and productive conversations. And just the fact that adult conversations are being had based on data perspectives, that in itself builds trust. And what is really interesting is differences in scores between different organizations. And that can lead to the team thinking, well, actually, we didn't tell you about that, or we didn't get you involved in this. So the whole team moves forward. So the reflections from this case study is just make time to speak about collaboration. Use the checklist questionnaire first, and then use the guide to understand what good looks like. Now, we can, as well as learning about how to do things, we can also learn by thinking about how not to do things. So myself and my research partner, we wrote a little pamphlet, which is the opposite of how to be great at collaborative innovation. It's how to be absolutely awful at it. This little pamphlet only takes 10 minutes to read. Is how can we be outstandingly successful, in fact world-class at preventing innovation, killing change, stifling creativity, and if any new thinking survives, make sure that it doesn't make a difference. So it's kind of the opposite view. So it's a little bit humorous and a little bit kind of tongue-in-cheek. So I'm just going to give you 2 or 3 examples out of that. The first one is about leadership, and I'm going to sort of quote from the pamphlet here. So the right type of leadership can play a massive part in preventing innovation. If you are naturally overbearing, domineering, lack any capacity to listen, and are not troubled by the burden of possessing any emotional intelligence, you're off to a great start. So it's clearly the opposite that we're after, but by looking at how not to do things, we can sometimes learn. If we think about trust, take every opportunity to diminish trust between team members, constrain the opportunity for informal conversations to happen, keep everything very stiff. And of course, there's an absolute classic to destroy trust. Remember, of course, to say one thing and do another. Getting back to the point about operational end user involvement and how our research found that involving end users at the front end is so important. If you want to stop innovation, if you want to kill collaboration in its tracks, don't involve the end user for as long as you can get away with it. Make sure that the innovation initiative is a total surprise. That always works to stop things. And I guess the last one I've got on this is about failure, fear, and blame. How many times do we hear about organizations that this is a no-blame organization? If you want to stop innovation, if you want to kill collaboration, always talk about how the organization has a blame-free culture, describe how valuable lessons can be learned from failure. In reality, make sure that you do entirely the opposite. Blame people when things go wrong and aim to make that blame personal. If you get this right, like ripples in a pond, waves of unspoken fear will spread out across the organization. So that's just a few examples of how not to do things. And of course, what we're after is the opposite, and you'll find how to do things is captured in our guide. You can download, if you email me at the address there, I can send you a copy of the innovation guide and the pamphlet. And I will leave us with one final message, which I'm going to borrow partly from Carl, who spoke yesterday. Water can't wait. We need to collaborate. Thank you.
Thank you, Tony. And what a powerful message to end this. Water can't wait. We need to collaborate. And this is coming from a person who has more than 40 years of experience worldwide in this sector. And the advices and messages that he was trying to deliver are kind of could be called the plan to succeed. Because in conferences, everywhere, and IDD is not an exception, we hear a lot of great ideas here and there, you know? But the question is, how can we make these ideas become a reality? How can we make those ideas turn into an actual impact? And this is why we have the next panel discussion with another leader in this sector globally who has also plus 40 years of experience in this field in many different countries and who was also successful to changing ideas into impact. That's why, help me with welcoming to the stage our moderator for this session, the chair of SWEC Advisory Board, Neil Reynolds.
Well, good afternoon, assalamu alaikum. As Mohammed said, my name is Neil Reynolds. I'm the chair of the SWEC Advisory Board. And before I obviously got involved in that, I have a global career, working most of my time with Fortune 500 companies. And I now serve a number of boards, both in the UK and, of course, in the Kingdom here. The board is advising mainly Watera, which is the innovation arm of SWEC, and that's on the domain of scientific, business, and public affairs. But most importantly, we're helping out putting in place an innovation model that is cross-cutting, flexible, that word collaborative again, and open. So open innovation is the theme that we're trying to run with Watera today. So I'm thrilled to be here, and today I'll guide an engaging discussion on the topic at the heart of progress and transformation, from ideas to impact, the importance of entrepreneurial ecosystems to create the next generation of innovations and entrepreneurs in water innovation. Over the past 3 days, we've listened to a lot of people here that have come with some brilliant ideas, and in the Global Prize for Desalination, we saw those 32 up on the stage. We've seen many case studies. We've seen enlightening panel conversations. But these mean nothing unless we can make real magic from these ideas and then take these and the momentum that they can produce to transform the way that we live, work, and interact with the world. That is what Ideas from Impact is all about. And in its local context, it's about the importance of entrepreneurship and its contribution to Saudi Vision 2030 and beyond, and the Saudi national economy. So during our time together, we will explore the challenges and triumphs of the transformative journey. We will discuss how to foster creativity, how to navigate obstacles, and how to leverage diverse perspectives for maximum impact. We will also dive into the practical steps and strategies our panelists representing government and private sector can offer and have employed to breathe life into ideas and turn them into real-world successes, not only into money, but also tangible and lasting impact that creates value for both businesses and the communities in which they are embedded. So that's the societal aspect of innovation. I firmly believe that sustainability will be the driver of innovation, and that open collaboration that we've heard Tony talk about too is the best way for businesses and society to address the complex challenges that humanity faces. So without further ado, I would like to invite our distinguished panelists up to the stage. They are here to share their wisdom and insights on the fascinating journey from ideas to impact. If I may first call Mazen Alghani, the Director of Empowering Innovation and Modern Technology at the Ministry of Environment, Water and Agriculture. Welcome, Mazen. Abdul Majid Al-Amrani, the Innovation General Manager at Monshat, a small and medium enterprises authority here in Saudi Arabia. Welcome. Avent Bazaidan Hood, the CEO of Earth Capital, who also works with early stage companies, is a venture capitalist with a focus on clean tech across the themes of energy, food, and water. And finally, Engineer Nasser Aldawani, the General Manager for Innovation at SWEC, and one of my colleagues. Thank you. So now that we've met our panelists, it's time to dive into hopefully an enriching dialogue. So given our limited time together, of course, maybe you can just obviously keep your answers fairly short. And if I may start now with Mazen initially. I say that because I look at the ministry as setting the framework, let's say, for the industry, particularly the industry that we're in. So collaboration is key for innovation success. I think we all know that. How can entrepreneurs, researchers, government, and financiers effectively collaborate and build strong partnerships to drive innovation and commercialization? I'd be particularly keen to learn about how that happens in Saudi Arabia, and I know that you have a number of programs that you're rolling out. Thank you.
Thank you so much. Thank you so much for this event. It's our pleasure here to be here in this such event with the SWIC. As you know, in entrepreneurship and innovation, we have two ecosystems. We have the macro ecosystem of innovation and entrepreneurship, and we have the micro ecosystem of innovation and entrepreneurship. And we in MIWA, Ministry of Environment, focus on developing and empowering the innovation and entrepreneurship ecosystem of each three sectors: EWA sector, environment, water, and agriculture. The minister himself announced 3 programs as an umbrella of this of the entrepreneurship in each sector. We have SIDRA, which the main purpose is to develop the ecosystem of entrepreneurship within environment sector. We have Sahaba, which is the role is to build the ecosystem within water, and also we have Sumbula, which is the main role is to build the ecosystem within agriculture sector. We work in to build the ecosystem within six components. First one is the policy and regulation, trying to making the regulatory reforms. The second factor and element is fund and investment. So we encourage and trying to motivate investment and investor to see the opportunities within EWA ecosystem, and focusly today is with water. The third one is market. So the main purpose in this element is to create a demand for innovative solution. The fourth one, when we talk about the human capital, which is one of the main goals. We try to help and to figure out where is the bright mindset, and trying to build up programs and building the community of entrepreneurship. Also, we have media and awareness, which we are. What we are here today is part of that. Is to highlight the promising, the promising solution, and to highlight the promising opportunities within these three sectors. And last but not least is support. So we work on supporting building infrastructure physical infrastructure, and also to give a consultation of entrepreneurship and innovations. So this is the 6 components that we are working on. We currently have a project that we consider it as a cornerstone for RDI activities in MIWA, which is technology deployment road mapping. We prioritize the innovative solution. We see where is the opportunities is in, and so on. So this is some of the current project that we are working on now.
No, thank you, Mazen. I think it was important to get that out first because I was trying to understand the type of guidelines that we can work with within the water industry. So thank you for that. If I may move on to you now, Abdul Majid. You represent Monshat. That's an organization, as I understand, that represents the small-scale companies, the SMEs. I don't know what percentage that is in Saudi Arabia, but all I know is that in most of the world, it's the backbone of the economy. So I would like to get your view on that. And if you could tell us exactly what Monshat is, what services do you provide, and how do you get access to those services, and how do they support the ministry itself to achieve its objectives?
First, I would like to thank our colleague at SWCC for such great conference, and it's our pleasure to be part of this great achievement. Back to your question, Neil, Munshaat was established in 2016 with the ambitions is to support SMEs to be the key engine of the economic development. Munshaat, the percentage of SMEs in terms of compared to the total economy in Saudi is contribute to around 99% of the total number of companies are SMEs. So for us as Munshaat, we are not alone. We are working with the government entities, with the private sector, with the NGOs as well, into supporting the creation of the ecosystem to support to the creation of startups and the sustainability of the existing SMEs. Underneath this, we are working in multiple pillars. Of course, the regulation and the policy making is a big role. We work with the government entities to make it more eco-friendly to the SMEs and startups. And even for policies, we have done several policies that enable the startups either to get deals, to access to fund, or also to get any kind of incentive to reduce the number of hours or days to get their business established. So besides the regulation part is the access to opportunities and access to deals. We are working with the government entities, with Giga Project, and with our colleagues in the private sector, especially in the corporate, to unlock their opportunities to the SMEs and to make it easier for them to sustain their quality and also to increase the local content in the Saudi. Also, financing and access to fund is the key. We have done several initiatives, including the establishment of the SME Bank and other initiatives to fill the gap of the funding life cycle of the SMEs in general. Besides that, we have built several programs and projects to support innovation and technology adoption. We believe in increasing the sustainability rate of SMEs globally is like 3 to 4 years with the 50%. That's why we believe that innovation and technology adoption with the support centers that nationally established in different cities, and also the virtual programs that we are doing, like the platforms in which you can access everywhere in Saudi, to increase this kind of sustainability rate and also to help support the growth of the SMEs. So I hope this.
No, that's excellent. And you picked up on a point that I'm going to ask the next panelist event, but you talked about access to finance. And if I can then bring you their event, in that I know myself supporting a number of SMEs and the CEOs that raising finance becomes a full-time job. If anything, the most important job. So you have the idea, but if you can't find the money to take it forward, you don't take it forward. It's as simple as that. And there's as many failures as there are successes. So if you could maybe just enlighten us, one, on the importance of that, and the service that you provide as a company at Earth Capital.
Thanks so much, Neil, and thanks for having me on the panel. I think it's so important, the funding part of it, and I think what we forget sometimes, I think what we've seen with the GPID awards, we've often got young, sort of really bright, talented scientists and engineers that have come up with innovations. But to get them fundable, they need a business plan, a strategy, they need HR, they need to build a team, they need to supply chains, they need to cost it. And then they can go to a financier and go, now I need money because it makes financial sense. But they've had no training in any of those things. They often haven't come from a corporate background where people have trained them to do that. And we expect them to be able to, because they came up with some brilliant technology, to be able to turn that into a business. And that just allows you to go to the financier in the first place. So I think the more we can do to support them and realize that you don't just jump from innovation to product. It's to help them get through those stages, know when they need different things at different times. And the way we can access those skills on their behalf, we can have expertise that we can bring in at non-exec level. You know, we can make the introductions to those organizations that would be so hard for them to access. And we can help them by introducing them to a network of other specialists that can support them on their journey. Because I think to get the financing is great, but it needs to be the right financing at the right time and to understand that it's being used in the right way.
No, thank you. I can't overemphasize what you said, I think, is that, again, certainly the companies that I deal with, the SMEs, they don't have the ability to lead. To me, like, that comes as a single point of failure very often, where very often they are accidental managers. So they've come into a business environment where they've had no leadership experience.
Yeah, I think in a large organization, you are, over a number of years, those senior managers have been developed. They've been sent on training courses. They've watched more senior people in action and have been prepared for the role. An innovator is suddenly thrown into the chief exec role and is expected to do all this stuff and create something where they haven't been prepared for any of it.
Yeah.
The fact that some of them ever survive and make a success is incredible.
And leadership, of course, can be trained too. So if I can move on to you, Nasser. So obviously I'm working with you, and I'm fully aware of the transformation program that we're going through, and particularly at Watera, to do more research and development, and obviously then take our ideas also into market. And if you can maybe just tell us a bit more about what exactly are Watera doing and its ambitions, not only in terms of what we're doing in Jubail and in Riyadh, but we have other plans as well to do things on the West Coast that we will be the leader in desalination in the years to come.
Yes, thank you, Neil. SWIC is investing heavily in research and development by Watera, with the planning to build a new researcher and innovation center that will be in Rabagh, in West Coast. That center will be one of the largest and advanced and most advanced in the world. This center will be equipped with the art of state of art in the facilities and equipment, and will be a team of the world-class researcher and scientists. Also with the Watera strategic partnerships with the internal and external university and technology provider. Watera now has 21 patents, most of them in the prime mining. Also, they have more than agreement with more than 20 entity inside Saudi or worldwide. Also, SWIC investing in the training and development programs to training people and let him ready to the working in or career in the water sector. Also, SWIC has Water Academy. The Water Academy offering more than 400 course and different course and program in water technology and supporting the innovation.
Good. So I'd like to maybe just delve into a bit deeper about how this ecosystem maybe is working then in Saudi Arabia. So we've touched on the ministry, we've got Monsat, we've got now SWEC, and we've got, let's say, an outside perspective. How exactly, and I'm going to maybe turn this to you, Abdul Majid, right now. Can you give us an example of maybe how this ecosystem is working in Saudi Arabia? Are you engaging with SWEC, for example, in terms of you have a collaborative agreement and you're offering services? So how exactly does it work?
Part of the beauty of having one vision is to have all the organization work to get toward this and to make it happen. We have worked with our ecosystem, including SWEC, in multiple projects, including the Saudi Innovation Center, which is focusing mainly on finding the supply to meet the demand that they have and to solve the big issues that they are facing. And this is like part of what we believe on unlocking the opportunities to the SMEs and the startups. Also, we work with multiple entities like to make it simple, every single entities that have strategy towards supporting SMEs, we are parting of that initiatives, including Ministry of Minor. We have multiple programs, including the Incubators Accelerator Program, Ministry of Information and Technology as well. So we work with the ecosystem to make it happen.
Thank you. And I'm going to now maybe move to a joint question, actually, across event as well, with you, Mazen, about entrepreneurs. We know they face challenges. That's a fact, particularly scaling challenges. So not just growth. I'm talking about scaling, and then scaling is actually getting all the resources that are needed in place. So how can we help them get beyond those initial Saudi Arabia? Is that also open to international firms coming in to help with localization, or is it just a Saudi program?
Okay. Thank you for these questions, and I think the key words and the key answer is collaboration. I like the words what Professor Tony said, successful innovation demands collaboration, and I really agree with that, and we really agree with that. Because with collaboration between each element of the leader of this element, like financial funds and financial bank or so on, and between also education. So with that, we can help and build environment that enhance the entrepreneurship and innovations. Because I strongly believe that we cannot solve and face the same the challenges by the same ways and methods we used to use before. We need collaboration, we need innovative solution, we need innovative also methods to face those future challenges. So we have several programs on that. We have a partnership with agriculture fund, environment funds, and also some SVCs, for example, Saudi Venture Capital Company, to encourage the investment in the startups and look at the opportunities in the EWA sector, environment, water, and agriculture.
And are these funds, these are funds that are generated from within the kingdom, or are you working with venture capitalists or private equity outside the kingdom?
No, not only locally. We are also invite the international funds and venture capitals to come and see the opportunity, especially water sector. We know SWIC is the leader in desalination, and I think there are many innovative solutions that we can work together and invest locally and internationally to build the innovative solutions for this sector. So we are looking for both international and local investment and funds.
And maybe I missed this, and I'll actually move this back to event in that very often in certainly the economies that I've worked in, there's always been a body that can provide grants. And for the small startup companies, grants are so important. And then, of course, you've got seed finance before it starts moving up the series. But can you maybe share some examples of some of the companies that you're working with in your portfolio where they do have a blend of grant and private equity as well as, or venture capitalism, as well as, the founder's money?
Yeah, actually, most of our portfolio has had grants along the way. So in the earlier days, they would have had government grants to prove the technology out. It's important, I think, to have that phase in. I think the angel round in the beginning can be very good, especially possibly that angel investor that can, come in and give expertise and work one-to-one, give small funding rounds to get to the next phase, and then bring in the right expertise until you're, so you get the help you need along the journey when at the right time. I think the grant funding is great. The one thing I would say, and we've seen this in the UK as well and in Europe, the government funding along the way is brilliant, but it's about making that access as flexible as possible, because I think, it's like this huge big tanker ship and a small little rowing boat trying to engage with each other, and one takes a long time to make decisions. The other one can't always wait long enough for that decision to be made. So it's about ensuring that there's a way for the communication to be sufficiently quick enough for people to access information and contacts at the right level, and to know how to get that funding. And that can be quite difficult.
Thank you, and of course then it's more than finance as well. So I'm going to move to you, Nasser, just quickly on the strategies that we're putting in place to help some of these collaborative initiatives that we have move forward. And the JIPIT is an example where there's going to be piloting, with the award. So what exactly are the services that we're going to be able to provide? How are we going to collaborate with our colleagues that have won the prize, and then turn those into value, not only for the entrepreneur, but for SWEC, for society? What's on your mind there?
Yeah, SWIC has implemented numbers of initiatives to promote research and development, innovation, and help entrepreneurs commercialize their ideas. SWIC Innovation Challenge, the GBID annual competition that award the prize to help the two startups that developing innovation in water technology. Also, SWIC has accelerator water program by Saudi Water Innovation Center. This center established in collaboration with Munshaat in 2019 with the 6-month program that provides startup access to mentorships and funding, also other resources to help them to develop the technology and their project from idea to commercialize.
Thank you. So what I'm hearing in this conversation, though, that there is already an ecosystem in Saudi Arabia to help, let's say, small entrepreneurs to start to move up. But if I can move back to you, Abdul-Mahdi, what about university spin-outs? I haven't really heard much about that, or maybe it's just the terminology that we're using, but these are ideas that have just come out of a university. And if you take, I know our colleagues from Oxford have been here, the Oxford spin-out program has been so successful. Do we have similar models here around KAUST or around King Abdullah University? Do we have anything that mirrors that here?
Speaking of universities, there is like R, D, and I. So in Munshaat, we are focused on the commercializable product and services that came out of the universities. The ultimate goal is to create startups because each university has its own way of commercializing their product, but our ultimate goal is to cooperate with university to create an innovative startup that can sustain and grow fastly. So we have a dedicated initiative called Startup University Program, in which we work with multiple universities to create first the community that support the entrepreneurial awareness, culture, and eventually the creation of startups. And also the programs including boot camps, hackathons, acceleration, incubation, just to help the spin-offs either from the faculty or the startup themselves, or cooperate with the industry to have these kind of ideas came into impact and create the jobs that we are looking for. And also we have what we call the bus tour among the some universities across the kingdom. More than 10 universities were participated, is to help the awareness and connect the dot between the university itself and the community around it, just to create this kind of open doors between the industrial need and the university resources, and eventually to have this kind of joint programs and initiatives to make it happen into the market.
Thank you. So that probably moves me on to like a bit of a joint question in a way. So what criteria do you look for, though? So I come along, I'm an entrepreneur, I have a great idea, and I come knocking on the door at the ministry or at SWEC or at a venture capitalist or at Monsat. What criteria maybe would you look for to consider that you should invest your time and money in that idea? And maybe if I start with you, Event.
So I don't know if everyone will agree with this. What I'm about to say might be controversial. We would pick a fantastic management team with an ever so slightly worse product over an amazing product with a rubbish management team. At the end of the day, it's the team that's going to deliver, and the team is crucial. I think it's really important to build the resources in that team because, markets change, the economy changes, and a really good team will be able to flex the product, they'll be able to pivot a bit, they'll be able to see new opportunities. Whereas, and for every one of these companies, times will be hard, and it's the best management teams are the ones that can guide that ship through that time and not give up. They can see a different way, they can see a route through the struggles. So for me, team is everything. That's got to be the number one.
Besides the team is the opportunity itself. So you have to have this kind of big problem to solve just to make it happen and to make it sustainable. And of course, sometimes the idea itself. But the idea could be changed and every time. So team play a crucial, diverse team, crucial in the success.
I just want to jump in with one really quick thing there because it reminded me of that, like my mentor when I was coming through in my career. But he always said to me is, every time I had a new company I found that I really liked, he'd go, but what's the customer pain? That was always his question, and he always used to drill that into me is, if there's a customer pain and your product can fix that customer pain, take that pain away, then there's a market for your product and someone will want it. So I think that's very key as well. It's great having a great innovation, but if nobody wants it and nobody needs it, no one's going to buy it.
Mazen.
Thank you. I totally agree with my colleagues. For us in MIWA, one of the main things that we consider is it a challenge solutions because we have faced many challenges in environment, water, and agriculture, and we are looking to build the security of water and food security and food and water security. So one of the main criteria is if that solution is helping to solve some of the challenges that we face. And also other criteria that my colleague mentioned, the team, the idea itself, and how it designed the business model that they have. So we have already designed some programs in incubation and acceleration to help to get these ideas in the floor and making new startups in the ecosystems.
Thank you. And same question, I think, to you, Nasser.
I think there is four main point we have to consider. The collaborating in development and research, also sharing the resources and expertise. The third one, invest in the startups. Also, the last one, advocating for innovation policies.
No, thank you. So I realize that we're probably at half an hour here, so I'm going to wrap this up. You may give me a similar actually answer to this, but if there was one thing, a piece of advice for an entrepreneur that you would give, what would that be? I'll start back with you on that one, Nasser.
Do your research and build your relations.
So relationships.
Yeah.
Mazen.
For me, collaboration, as I told you, collaboration between all the elements can make the key result. So I think this is the key word that we can.
Focus on your customer, not too passionate about your idea.
Yeah, I'd agree. This goes back to that customer pain thing, I think is very key. And to keep going, because it's going to get hard and it's not going, I think we all see the stories of, I came up with a new business plan today and the next day I sell it for $1 billion. That's, in my experience, it sounds wonderful, but it's a lot more hard work involved in that. It's not quite that simple.
If I can add to that, I think from myself, and again, from what I see, is that I very often, when I talk to CEOs, we have a conversation about, do you want to flounder or do you want to fly? And of course they want to fly. But what do they need to help them fly? And in most of my cases on the small company boards that I sit on, they need a coach, they need a mentor. Sometimes they're interchangeable, but certainly reaching out into the community. Don't think you can do it yourself. So that word collaborate that we've heard so many times today is probably the most important word that we've discussed throughout the whole last couple of days. I think collaboration, open innovation, that's when things happen. They don't happen in isolation. So thank you, ladies and gentlemen. If you can just give it up for our panel, a short applause. Thank you.
Thank you so much, Neil, Nasser, Mazen, Abdelmajid, and of course, Avent. If you have noticed, after the lunch break, we started off with Tony Conway giving us the roadmap towards being successful and implementing those innovation plans. And later on, we reached with Neil and the experts talking about how important it is to collaborate to make that succeed, ensured. And right now, like what Avon just said, she was talking about the importance of team and team collaboration, but what's the point of having a team if that team doesn't have a good leader, right? So that's why our next panel discussion is going to be about building desalination leaders and future technical experts. I'm glad to welcome on stage our moderator for this session, who's the desalination advisor at the German Agency for International Cooperation. Please give it up to Mu'tasim Abu Sha'ban.
Thank you, Muhammad. Good afternoon, ladies and gentlemen. So we spent the last 3 days talking about innovation in desalination, and I think young leaders play a crucial role in developing new solutions and new innovative ideas. So, because they are the new generation and they are the future leaders and technical experts. So, in this panel, I will discuss with the three talented leaders. We will talk about the role of young leaders in desalination, what issues and the challenges they could face during their journey, and at the end, we will discuss also the gap between the academia and industry. So for this, I would like to invite our speakers here. Firstly, Engineer Mariam Oda. She's a PhD student at Khalifa University with research focus on developing compact and self-cleaning ultrafiltration system. Dr. Christine Klinfer. She's a process engineer and senior researcher at Cologne Membrane Lab of University of Applied Science in Cologne in Germany. And last but not least, Engineer Karim Habayeb. He currently holds the position of Special Projects and Business Development Manager at Gradient Corporation. His focus on minimum and zero liquid discharge system, as well as artificial intelligence in water. Thank you, and welcome Karim, welcome Mariam, welcome Christine. So let me start with you, Mariam. Mariam, you have contributed in more than 20 research papers during the last few years in the field of water and wastewater treatment, and however, you are still young. So I would like to know the importance of innovation in desalination from your perspective and from your point of view.
Hi, everyone. Thank you for the very nice opportunity to be here among worldwide experts. For me, the importance of innovation comes due to, first of all, the extreme freshwater scarcity in regions such as the one that we live in. We live in a very arid region, so the access to freshwater resources are very low, so there is a very high demand and a very low supply. The high demand is also due to the continuous growth in population. So this is where innovation comes in. We need innovative solutions to keep up with this very high demand and low supply.
So you were talking about reducing the energy consumption, etc. So what kind of, what challenges and opportunities in the field of desalination we could face during your journey, or any young leader or professional could face during his journey?
Okay, so the challenges, let's start first of all with the challenges. The challenges of desalination comes due to the very high energy consumption of the desalination process, which not only has very high costs, but it also puts strain on the resources that we have, and it contributes to the greenhouse emission gases. Another challenge is the brine disposal. So the brine disposal, it has very high effect on the marine life, etc. The opportunities that lie in desalination are, first of all, the ability to harness renewable energy, such as power and wind, in order to reduce the strain on the resources, on the limited fossil fuels that we have. And another opportunity comes from the brine mining, which we saw many of in the past few days. So a major opportunity comes. Instead of disposing the brine, we can recover it and we will have value added. So we'll not only have reduced environmental impact, but we can also recover its costs. Opportunities are many, many. It's not only one or two. And I'm sure there are so many opportunities more to come, but to put it into perspective, just to name a few more. We have chemical-free desalination. We dose chemicals throughout the entire process. So we have a major opportunity, a major place to do some research is to, can we think of methods in order to reduce this chemical input to the plant and reduce this marine discharge. And we also live in a very in a material era, so we have hundreds, if not thousands, of materials coming out every day. These materials, they can be tuned in order to increase the efficiency, and at the same time, it can all be under the umbrella of green chemistry and sustainable future. And finally, we have the ability to make use of artificial intelligence, which we saw also in the conference, throughout parts of the conference. This we didn't have before, so we can utilize this in order to reduce the energy costs and enhance the efficiency of the process.
Okay, thank you very much, Mariam. So, Karim, maybe I move to you, and you work mainly in a brine and zero liquid discharge. So, would you consider that as a challenge or as an opportunity? So, what do you think?
So, it's starting off as a challenge. It started off as a challenge, but the more the industry is maturing, the more it's becoming an opportunity. And especially in this region, given the environmental regulations and the government mandates put in place, it's becoming more and more lucrative to pursue brine mining and to further concentrate brine and develop technologies around that. You really need a push from the top if you want to make brine mining feasible, for it to make economic sense, because it really needs regulation more than anything.
Thank you. Maybe I would like also to hear your opinion, Christine, about the challenges and opportunities in the field of desalination. Would you please comment on that?
Yes, of course. I think that the realization of a sustainable circular economy is what drives us at the moment. We have to implement the industrial transformation accordingly to that, and I see also the brine mining field and how we can increase energy and resource efficiency in all the existing processes. Which means, in my case, for example, I'm trying to position pressure-driven or high-pressure-driven membrane processes reasonably to increase energy and resource efficiency in processes and extract valuables from wastewaters.
Thank you. Maybe back to you, Mariam. You are young leader. You are member of the Young Leader Program within the International Desalination Association. So, as a young leader, what role you can play to develop new desalination technologies and innovative ideas in the field of desalination?
Okay, so first of all, what role do we play? We are a generation that's very rebellion. We tend to think outside the box. We don't listen to what we're told unless we see it ourselves. So this is where we can bring in fresh ideas, new perspectives, and we can deviate from conventional technologies. So that's first of all. Second of all, more than ever before, we can look at us. We're 4 different people from 4 different regions. We're we're collaborating, sitting on one table, speaking the same language in order to think together outside the box and really come up with new ideas. And third of all, and a very important aspect, although many industrial people might not agree with it, is that environmental awareness has been embedded in our education. We are not the generation that started climate change. We are the generation that's going to hopefully mitigate it. So I, for once, have been taught about environmental awareness from elementary school, if not before. So the basics of reduce, reuse, recycle, and how to make environmentally aware decisions. This becomes important when we have to intuitively make environmental decisions. A big example is that how emerging contaminants did not gain attention before regulations started coming in order to put, limitations on their discharge. I really believe if it was 20 years or 10 years into the future, we can factor in the cost of the environmental cost. We can factor the environmental cost within the cost of reducing these chemicals before disposal. We can do it intuitively without even thinking, and without even thinking in the way that the older generation thinks. So to answer your question, I really think that we have 3 roles to play. First of all, the fresh ideas, the deviation away from the conventional methods, the ability to collaborate, and the environmental awareness that was embedded in the education system.
Thank you. Christine, you work in academia. At the same time, you have also a job as a process engineer in industry. So based on your experience in both, first, what's your understanding of needs-based research, and what kind of research and future ideas we need to develop in the future based on your experience from both sectors?
Okay, what I see from my experience is that industry often needs pragmatic solutions, pragmatic technical solutions that can be implemented in the near future. So this is often due to new regulations, for example. And the challenge I face here with my research is that we have existing processes, existing systems, and we have to think about how to implement and how to insert and complement those systems with a new technology, with new ideas. As a process engineer, I also see a chance there because we already have an infrastructure we can use. So yeah, the requirement would be that we need new ideas, how to combine maybe also existing technology to find a solution. And that is the position where I am performing as an applied engineer and applied scientist. I'm always trying to find available equipment and bring it into completely new applications or in terms of operating conditions. I push it to the limit and I do a feasibility study and I look at how does it work and how can it be optimized for this special application. Yeah.
Yes, thank you. So maybe Karim, you work in industry, and maybe you can comment on the needs for academia. Do you really need academia for your industry work, or you don't really need that academia background?
So academia is extremely important because it's developing innovation in a controlled environment. So you really have a chance to iterate your technology and develop it without much risk or real-world consequences being put into place. Whereas if you're in the industry and you have a technology that's being developed and you take it out in the field and that technology fails or something, there's a lot more at stake there. And it could be a lot more costly, it could have consequences. I'm not saying that in academia you don't have consequences to failures in technology or something of the sort, but it's just because you have that safety net, you are able to really disrupt and innovate further without having to worry too much about the real world applications and the politics that comes along with that. So the bridge between academia and industry is extremely important, and it's very important for academia to stay in touch with industry, to kind of understand what the actual current trends are, and for industry to also stay up to date with the current technologies in academia so that they can figure out if there's a technology out there that can actually help them improve their process or something of the sort, which is why conferences like this and organizations like the IDA and things like that help bridge that gap and really introduce each other.
Thank you. Christine, can you comment on the role, how we can collaborate between academia and industry?
I think we heard it several times today that the collaboration between academia and industry is absolutely crucial. Not only with, for me especially, I mean, my research is living from that, and not only with technology users, but also with technology providers. And yeah, I think that your network has to be international to identify and conduct needs-based research. I also think that we would need platforms and force those communication between industry, academia, and also regulating organizations like the government to close this gap that is still existing, I think, between research and industry. Yeah, thank you.
Okay, so since you work in both academia and industry, what has supported you during your way to develop yourself and to be a young leader?
Yeah, at a very early stage in my academic career, when I was doing my PhD, also due to industrial collaboration, I had the chance to present my work at an IDA conference, an international big conference, and that was when I got introduced to the Young Leader program. I was asked to be a mentee, and I had a phenomenal mentor. Then he helped me to see the whole picture, and he helped me to get introduced in the scientific community, in the industrial community, and that absolutely advanced my opportunities.
So you mentioned about mentorship program. So what's mentorship program and what do you do in it?
At the moment now, I'm acting as a technical coordinator for the mentorship program. At the moment, we are also launching a new version of the mentorship program. It will be out very soon. The mentorship program is practically we pair one of the leaders of the scientific community, the industry, with one being in its early stages of the career. And this is just a great initiative to advance opportunities, to exchange ideas between experts, and to develop further.
Okay, thank you. So Karim, I think you have an inspiring success story here, and you were able to commercialize work from the lab to the commercial level. So would you please give us a little background on your journey and how you were able to commercialize the technology, any new technology as well?
Yeah, sure. So at Gradient, we actually started in the labs, so in the MIT labs, and we've since developed the technology there. And through partnerships and people that have helped out a lot and connection, like networking, we were able to get a pilot, a couple pilots. Well, initially started with one, then several others, and from these pilots we were able to expand into a commercial project. And I think one of the main things that that was, I guess, the most helpful in the journey is really the people that helped out. And again, conferences like these and people at conferences like these that have helped out the company make the correct introductions to the correct people, the correct investors, the correct partners and clients. And that enabled us to develop the product and iterate it again and again until we perfected it for commercialization.
Okay, can you elaborate what kind of technology have you commercialized and what do you do for?
So I'll focus, I guess, on CFRO, which is our brine minimization technology, and that was developed in Boston, and I was personally involved in the Saudi market, where we we collaborated with a company called Sawako here in Saudi, and through the partnership and collaboration, we were able to develop a pilot, and that we started in 2018, 2019, like end of 2018, 2019. And initially, the whole objective was we get the pilot, and then as soon as it's successful, we roll out the commercial project. And it doesn't work that way, unfortunately. There's a lot of challenges that you face along the way. I mean, we also had COVID that struck in, and that was kind of bad luck. That kind of slowed us down, and then I'm glad that kind of happened as well, because we were able to improve the technology through that pilot, and we're able to give a better commercial solution to our clients as well.
Okay.
So yeah, that's kind of the journey, I guess.
Nice, interesting.
And now we have a plant now operational in Jeddah.
Jeddah, okay.
Yeah.
Nice. So from your perspective, what's the most important step in commercializing any technology? So Mariam, before she mentioned about the artificial intelligence. So is that important or not important in the commercialization?
Oh, so commercializing artificial intelligence. Commercializing artificial intelligence and machine learning and, like, I guess, more software-based solutions is different than system-based solutions. For one, it's much easier to roll out to systems because of the capital cost that's associated to that. So you can go to clients and offer it as a free package or a free trial in the beginning and then develop it like that. Whereas when you're trying to pilot a system with a client, it can cost you a couple $100,000, sometimes $1 million, and then that becomes a lot harder to swallow in your budget or in your client's budget. So yeah, the adoption of AI and ML is or at least trying it out and getting clients to try it out is much easier in my experience, because we've done both actually. We're also doing AI and ML here with a couple of companies in Saudi, and from my experience it went a lot quicker. The introduction to that went a lot quicker than when we were introducing CFRO.
Okay, it went quicker. So out of curiosity, how long it took you to commercialize your lab idea or the new technology to the commercial level?
So actually our technology started before I even joined Gradient. So I would say it took us about 8 years to commercialize it, I want to say. Plus or minus 2, I guess, depends on when you officially decide that the technology started and that we really started researching and piloting it, which I think is fairly quick, honestly, especially in the water sector, given the water sector is not usually one of the industries that's very adaptable to new technology. They're very embedded in their old technologies, because what you're doing is you're displacing an older technology for a client. So your client already has his capital sunk into that technology, his knowledge that he's accumulated, him and his team has accumulated in that technology. So you're basically telling your client, forget all of that and use us. So sometimes it takes time, and the most important thing is, I guess, to take your time while developing it and rolling it out, as opposed to rushing through it, because when you rush through it and you make mistakes, you can, like, yeah, on average, maybe it takes 10 years, but a lot of people develop it and then they fail, you know, and so slow and steady rather than go quick and expand quick, I guess.
Okay, thank you very much. We are running out of the time, but I would like to wrap up with a small question for you, Christina and Mariam. What's your advice for young leader professionals in general?
Definitely get involved with industry, get involved with scientific community, and communicate where and whenever you are able to. Take your opportunities to do that, and maybe also an advice for the industrial part. So provide those insights and yeah, provide attractive internships and maybe even through research.
Thank you. Mariam?
I think I'm the one that needs advice, but I'll say from my perspective is that don't get carried away into one industry. Don't be very research intensive, and at the same time, don't be very industry intense. I mean, don't choose one or the other. It's important to keep an eye on both, and don't get carried away with the research, and don't get carried away with the industry. So it's important this collaboration between the two, and to keep closing the gap, bridging the gap rather than increasing the gap is very important. So it's important to keep an eye on both, which is what I'm trying to do. Thank you.
Thank you. Karim, do you have any?
Yeah, I guess develop your knowledge and expand your network as much as you can. Figure out what you like and expand on that.
Okay, thank you very much. With this, I would like to thank our panelists today, and I would like also to invite any young leader, a professional, if he or she would like to join the International Desalination Association Young Leader Program. He could reach, or you could reach any of us today or later on by email, and thank you very much for being here.
Thank you, Mu'tasim, Christine, Kareem, and Miriam. Thank you for this rich session. And you guys just gave the roadmap for young people on how to become good and successful leaders. Ladies and gents, for the final session that we have today, and to end with it, the IDD conference in its second version, I'd like to remind you, and some of you probably weren't with us a few days ago, specifically on Saturday, where we celebrated the GPID Awards, a competition that lasted for almost a year or so and was finalized by Saturday. So for you who've missed it, we're going to give you an opportunity to see the presentations for the winner and the 3 finalists who managed to reach to that point. So without any further ado, let's welcome the winner of the GPID Award and the winning presentation. Let's give it up to Sayyid Shah. Congratulations. Thank you. You can use this to go forward and this one to go back.
Assalamu alaikum. Thank you very much for giving me this opportunity to talk about our technology. I want to start off by saying, Aqua Membranes, the company that developed this very groundbreaking printing technology, that journey started many, many years ago. And it started because we looked at innovation in water filtration, and then specifically in reverse osmosis technology, the primary filtration system that is used in desalination plant as well as a lot of other industries, such as wastewater, agriculture, semiconductor industries, and so on. And what we realized is that innovation in water was limited anyway, but in reverse osmosis, it was more so. Yes, there were innovations around RO membranes and on the permeate carrier to help with the transportation of water through the membranes, to help with the salt rejection. But the biggest culprit was the feed spacer, the plastic mesh that is still in all of the RO cartridges. Okay.
This one makes the screen black.
Oh, sorry. Okay. So we embarked on this journey to see what we could do to eliminate, not optimize, but absolutely eliminate the feed spacer from RO elements. And that's how we came to our innovative 3D spacer printing technology that's augmented by artificial intelligence. A few of the speakers before me, they talked about being pragmatic, having a solution that's pragmatic, and even talked about the pain point. What is the pain point that customers have? And when we look at desalination, the biggest pain point is using high levels of energy, having a lot of wastewater, having a lot of plastic waste. So we kept all of those pain points and said, what can we do that can kill two birds with one stone? What is that one solution that can attack most of these pain points? And fortunately, what we found is the solution that we came up with eliminates multiple. It kills multiple birds with that one technology, which is removing the feed spacer and implementing our 3D printing pillars. So imagine a river where water is flowing. The current RO elements has that spacer that acts as a dam, and you are trying to push the water through this dam. That's your high energy, and that's your high waste of water. And our technology can be thought of as rocks in the river. So imagine how the water just flows around the rocks. Because the primary reason for using a feed spacer is really to channel the feed water and to separate the membrane layers. So by eliminating that and putting in our printing technology, we basically eliminate all of the waste. And that's what you see in this diagram. The feed spacer is now replaced by a specialized printing. It's an acrylic photopolymer print that can withstand high pressures, that can withstand high saline conditions, acidic conditions, without leaching, without breaking away. It's always there. And that is what took us years to develop. And that's why we believe this is a disruptive technology that will be employed throughout the globe in RO membrane technology, because there's no other reason why RO membranes would have to be manufactured in the current process. This is a chart I showed on the first day of the presentation, but what basically it shows is the top two lines. The top line is the feed pressure from a regular RO element, what is currently used in industry. And that second blue line, that is the feed pressure for using our technology. So same permeate water output, same output of water, you now immediately have a 20% reduction in the feed pressure. That is your energy savings. That is reduction of stress on the pumps that's pushing the water through. That is your electrical savings. And then something that was really mind-blowing even for us is when we looked at the pressure drop across the element. That is the second pain point, which is the fouling. I spoke with a lot of leaders of desalination plant during these last few days, and they showed me photos of immense fouling. 10 to 20% of desalination RO elements are replaced on an annual basis, and some of them are being replaced every 3 months. So imagine shutting down the plant, trying to replace all these elements, the cost of the element, the scheduling of the plant shutdowns. So none of that energy savings was even shown by my next slide. The next slide that I'm going to show is just the energy savings from utilizing our RO. But when you look at the holistic energy savings, it is just incredible. All the way from your accessory equipment, your downstream equipment, pumping the waters through the RO membranes, replacement of RO membranes, things that you were replacing once every 3 months, once every 6 months. Imagine now telling your maintenance folks, you don't have to replace it for 2 to 3 years. You can keep the plant running. It's just incredible. So the bottom two lines, the yellow line shows a standard RO element, the pressure drop across the element. And look at the green line, that's our technology. There is virtually no pressure drop. The pressure drop of 3 to 4 psi across the element remains pretty much consistent months and months after use. We had to cut the data. We're still running this experiment. And what it's showing is that yellow line is now exponentially rising, meaning the element is dying. Whereas ours just keeps on going. We used to have this advertisement in the US, the Energizer Bunny, I don't know if anyone's familiar with that. You know, it just keeps going and going and going. And that's what our data shows. And we're so excited about that. And so this was a slide that I presented that really shows the private desalination companies, the amount of water that they process. It's in billions of gallons. And these are just private companies. This doesn't incorporate all private companies. It does not even incorporate public companies, municipalities, co-ops, IOUs, the works. So this number, the amount of water that's processed, can be multiple folds of what I'm showing over here. But just with this data, and just with the savings that we have proven, it results in millions of kilowatt hours of savings. It's just incredible. And Aqua Membranes is a leader in this. No other company globally has looked at eliminating feed spaces. We are now using artificial intelligence to augment and customize specific patterns. So we have a specific model that patterns and that the print on the membrane to maximize the flow, to reduce scale, and to really minimize to the highest degree the fouling, the culprit that's costing desalination plants and industries across the globe millions or billions of dollars in OpEx and CapEx. So we're really excited to be on this journey, and I appreciate this platform that was given to us to showcase. I am an absolute believer that Saudi Arabia is leading the charge in innovation in this field, and we're excited to be part of this journey to showcase and employ our technology. I'm really appreciative of the fact that we are being given the opportunity to pilot our technology here, and we are absolutely confident that over the next few months, the data is going to be astounding, and that this technology is going to be employed rapidly throughout the region. So thank you very much for that. And before I leave, I want to congratulate my fellow finalists as well for their innovative technology. One of the greatest things about this platform is for us to collaborate. It gave me a good understanding of all the other innovations that are going around, and I'm looking forward to collaborating with my team members over here, as well as the other presenters for all their technologies, to really come up with a system that can be a super system, right? So if we can get the best of the pre-treatment, the best of the RO membrane technology, and then employ that, that's going to be a game changer. So thank you very much for your time. Thank you.
Well done, Sayed, and congratulations once again. And now we're going to see the 3 more presentations for the finalists, starting with a randomly order. I would like to invite on stage Arian Edalat.
Okay, hello everyone. My name is Arian Edalat. My team and myself, although Active Membrane is a relatively new company, it's always been in operation for the past couple of years. My team and myself, we have decades of experience in developing, designing and operating desalination, membrane-based desalination solutions all over the world. And in all of the projects that we've done during the last 2 decades or so, and everything that we've done, at the heart of it laid the fact that membranes as they are, the process of passive separation, separating water, passing water through the membrane and separating the salt, always comes with either a scaling, which refers to accumulation of supersaturated mineral salts on the surface of the membrane, or various other impurities that may make the membrane clog and lose its efficiency and eventually its life. Everything in a desalination plant, everything, all the way from the intake to the outtake, is designed around the fact to mitigate scaling and fouling. Constitutes about 60 to 70% cost of capital and operating costs to actually mitigate the scaling. That's what makes desalination, more often than not, a technology of last resort as opposed to a technology of choice. Membranes are, they don't have any means. They just sit there and take the water that comes to them. They don't have any means of defending themselves against scaling and fouling, and they eventually reside on the processes upstream, the pretreatment and otherwise, to control it for them. Now, we have always had one thought: how can we change that? How can we enable the membrane to have means of controlling scaling and fouling on its own without having to reside on upstream processes? And that's what we've developed at Active Membrane. Our membranes are electrically conducting membranes. They are smart membranes. And by the virtue of being electrically conducting, they have the means of defending themselves, utilizing a small voltage, a small tunable voltage, depending on the water quality, and defending themselves against fouling and scaling. Now, these are the spiral wound modules. They fit in any desalination plants. They come from 2.5 inches all the way up to 8 inches, from your households all the way up to commercial plants, drop-in replacement. And a membrane that can think, and a membrane that can defend itself against the water quality, come what may, has a significant impact on the way we do desalination. And that impact comes in many forms and fashions. You would significantly reduce the footprint of the plant. You would increase the recovery, which means that your intake and outtake is going to be smaller. Everything in between, all the cost centers in between, either going to be eliminated or downsized one way or another. And that is how we see reducing the cost of desalination and making it a technology of choice as opposed to a technology of last resort. The technology itself right now is going through a scale-up. Soon we'll have the 4 inches and the 8 inches element in the next couple of months or so, and is open to piloting to any applications in any of your plants if anybody is currently interested in it. We have had a lot of success. The US government gets it. We've been given a lot of field pilot grants. The technology has been nominated as a Water Technology Idol earlier this year. This prize, I would like to thank SWEC and all of you here in Saudi Arabia for giving us this platform to represent our technology, to make some headways on it. It has been an exceptionally great opportunity, and I would like to thank you on behalf of myself and my colleagues for your generous hospitality. We look forward to working with SWEC and everybody else to pilot the technology here in Saudi Arabia, and together hopefully we'll solve the problems of water scarcity, not only here but all over the world, because this is an existential human crisis, and we want to redefine the option that is desalination. Thank you so much.
Thank you, Ariane. It's a pleasure having you with us, and congratulations for reaching to becoming one of the finalists. Now, to go to the other finalist for today, I'd like to invite on stage Mohammed Anwar.
Thank you. Hello, everyone. My name is Muhammad Anwar, and I'm the Global Business Development Director for Schneider Electric for the smart water and digital transformation in the water segment. In fact, when we started this journey and participating in the GPID, we were thinking about what could be the challenge and what can we do as one of the major technology companies and players in the market that can facilitate and improve the operations inside the water desalination plants. And when we think about that, we come across multiple challenges that are happening in the water desalination plants. And one of the things are how can we make the entire operation inside the plant more efficient, resilient, and of course at the end more sustainable. And this is where we were thinking about and putting ourselves in the shoes of the operator, in the shoes of the plant manager, of the production manager, and then we think about what could be the challenge that they are facing and what could be the dream solution for them. And of course, I would insist on the message that Mr. Said Shah put in place, that when we talk about the technology that we have been included in the top 6 finalists for, and we are very proud of that. But at the end, what will be really breaking through is how we are going to incorporate all of these solutions together, and then at the end, that will bring a huge value for the industry itself, and of course for the sustainability of our planet. And I will go back again to the story, and when we started developing this solution, so we found that one of the challenge is the operator coming in the shift or in the beginning of his shift, and he needs to operate the plant to provide the targeted production in terms of quantity of water or volume of water that they need to provide for his shift or for today or whatever. But now, when the operator goes and decide how they are going to proceed and produce that amount of water, they go with the standard flow, with the most possible capacity in order to produce that water. And that could not be really the most optimized operational points in different parts of the plant. And when we started to work on that and see and analyze what can we do to facilitate the life of the operator and the other stakeholders inside the operations life cycle, we found that, our team came up with the solution that target to represent the entire plant from physical plant into digital plant. And this is the first step. And then empower that digital representation with dynamic simulation, with machine learning and AI, that at the end enables the operator when he just say that I need to produce today 1 million cubic meter of water, the model directly simulate and provide to him the most optimized set points in different aspects and in different stages of the production plant. And that would be something really meaningful for the operator. And of course, it has by default saving in the energy, it's saving in the chemical dosing, improving the life cycle of the assets inside the plant, talking about the high pressure pump, talking about the membrane, early fouling detection, and all of these use cases that will be embedded inside the model that, again, as I said, will be empowered by the dynamic simulation and artificial intelligence and machine learning. And why considering that as a kind of innovation? And I will be frank with you, as Schneider Electric, we have done the dynamic simulation already in different fields. But when it comes to the desalination process, it's a kind of complicated and specialized process that the parameters are dynamically and continuously changing throughout the life cycle of the operation. And that's why it is very challenging to have a kind of credible dynamic simulation model and then, of course, empower that with the machine learning and AI. And that's why we consider it really an innovative. But when we go back, how we are going to do that in reality, so we start first by, as we said in the beginning, converting the physical plant into digital plant. And this is what we call the digital twin. And we start that journey from the early beginning of building the plant, where we start with the engineering. And from the beginning, we create all the assets that we have in the plant as digital assets. And why that is important? Because once we create the asset as digital assets, that will enable us to attach any type of data related to that asset to the digital representation of that asset. And that could be engineering data, that could be operational data, that could be maintenance data, historical data, alarms, any type of data related to that asset can be directly attached to that asset, because again, at the end, it is a digital asset and it's data. And this is easy to have once we have that digital asset there. And this is what we do when we start from the beginning, from the engineering. We start by creating the digital assets, considering all different parameters related to the assets when it comes from the engineering perspective, starting from designing, engineering, handover, training, single line diagram, P&ID, everything, until we go into the testing and commissioning. And of course, throughout that, we use the engineering simulation tools that simulate the plant. And we keep all this data, very rich amount of data, that we take again into the operational efficiency, where we continuously attach the different types of data related to the operation and maintenance to the assets. And you can imagine, if you come after 5 years of operation, how much amount of data that we will have for that operational plant. It will be huge, because we are representing it in digital twin, and we are attaching all the data. And that huge amount of data is really what we are going to use to make better decisions in the operations, and accordingly optimize our operational set point, saving energy and increasing the life cycle of the plant. And with this amount of data, we empower that digital twin with the comprehensive dynamic simulation for the entire plant that considers continuously all the changing parameters of the elements inside the desalination plant. And again, this is where we are, of course, addressing one of the biggest challenges in this application. By having that, we will be able to simulate the entire process. And of course, as I mentioned, addressing and increasing the efficiency of the operational plant, addressing the profitability, because we address to reduce, and as per many of the use cases that we are working on now, to reduce around 7%, 5 to 7% of the energy consumption, chemical dosing, increasing the life cycle of the assets inside the plant, as I mentioned, including membranes and high pressure pumps and others. But of course, it provides a very powerful decision support center to the stakeholders. And these stakeholders or decision makers could be the operators, as we said earlier. It could be the production manager. It could be the maintenance manager, because at any point of time, they can reach to the model that is, again, empowered by the dynamic simulation and the AI, and they can reach that model, and that will advise them to the information that they need and the optimized or the right decision that they need to take for their operations. And finally, the way we see it, that we change the plant and we change the way that the operators are operating the plant to the way that we are using our smartphones, where we have an operating system, iOS or Android or whatever, and over there we have different applications that we use throughout our life. And this is what we are aiming to have with empowering that digital twin that will be the platform with the different models and applications that will be used in the operations by the operators. So thanks a lot for your time. We are very proud to participate. We would like to thank SWEC for inviting us for this prestigious event, and we will continuously improve our solution and participate in that. Thanks a lot.
Thank you so much, Mohammed. Congratulations once more for being one of the finalists. And last but not least, regarding the finalists, I'd like to invite on stage Quantum Way.
Good afternoon, everyone. At Harmony Desalting, we treat water in batches to achieve ultimate energy efficiency. Now, continuous reverse osmosis is a conventional way of performing desalination. It's worked for us for decades. Why treat water in batches? Well, in some sense, batch desalination is the simplest way of performing desalination. You're just pushing salty water against a membrane, producing fresh water. We've hit a wall with continuous RO in terms of energy consumption. Now, why is that? Reverse osmosis consumes a lot of energy because of the high pressures involved. To understand a bit about how that works, you have to think about the osmotic pressure. The osmotic pressure defines how much pressure you need to push water through a membrane and produce drinkable water. I mean, let's just keep it simple and look at the picture. With conventional RO, you're applying a steady high pressure, and with batch RO, instead of constantly applying the highest pressures, we start at the lowest pressures and work up to the highest pressures. We track the osmotic pressure curve. This is the most energy efficient way to perform desalination. I mean, if you look at this photo, if you look at this diagram, this doesn't look like a desalination system. But we've reduced this idea to practice. So rather than, we've completed 2 field trials in Arizona and Canada, small systems for brackish water desalination. There is high. Our systems use standard desalination equipment. So our systems use standard desalination equipment, all off-the-shelf parts, standard spiral wound membranes, standard pressure vessels. We add a custom component, a bladder. This bladder could be very similar to the bladders that are used in bladder pressure tanks, which are used in residential water treatment systems all over the world. We think this technology is ultimately really scalable. Basically, the additional equipment that we add to a standard desal process is actuated valves, that bladder pressure tank I referred to, and some extra water tanks. So we really appreciate this recognition from the GPID and SWIC, and we're looking forward to piloting our technology at the larger pressures required for seawater desalination and eventually scaling up to the size plants that you see on the right over here. Now, the name of the game is reducing the levelized cost of water. And with batch RO, we think there are 3 ways of achieving that. The first is energy efficiency. As I explained not so well earlier, batch RO is, we think, the most practical way of achieving low energy reverse osmosis. And we compare this with many of the membrane innovations which we've seen earlier today. We can operate plants at increased intensity. In those conventional RO systems, the reason they produce so much energy is because the flux is very high at the beginning of the system. The flux is imbalanced. In our processes, in our batch RO process, because we recirculate the feed, the flux is much more balanced. The flux that the lead elements are much shorter. We can avoid fouling and increase the membrane productivity, all while keeping the energy consumption at a reasonable level. So we can make more use of the membranes, stop operating these systems where the membranes at the back are barely producing any water at all. And finally, we can be more water wise by increasing the recovery of these systems, reducing the brine output, reducing the size that's required for these massive construction projects, large intakes and outfalls. In terms of energy efficiency, I think we can go beyond seawater desalination into brine mining, where you've got those high pressures that were shown at on that first slide, 120 bar. Higher pressure means more energy, and that's where I think this process can really shine. Thanks for bearing with me. Appreciate the invitation and the support. Thank you.
Thank you, Quantum, and congratulations once again for being one of the finalists. Ladies and gents, I know it's been a long day, but last but not least, I would like to invite to the stage the co-chair of the International Jury of the GPID Award. Please give it up to Tom Pankratz.
Thanks for that. And as we are wrapping up this event, I would like to take the opportunity on behalf of my colleagues on the GPID jury, the desalination community, and everyone who drinks water to thank His Excellency, the Governor of SWIC, for initiating or taking the initiative to plan this event, carry it out, and give all the technologies and the, in many cases, young researchers an opportunity to show you something that you might not otherwise see for a couple of years at the more conventional conferences and events on desalination. So we've seen some really good stuff. It gave the jurists who had a chance to look at all 105 proposals a real good opportunity to see other things that are coming in the future. And that's what leads me to come up here today is to, I'm able to report that His Excellency has confirmed some important changes for the 2024 GPDI event. First, he has said that the number of winners and the prize amounts will be doubled for next year. We'll also double the number hope to double the number of applicants and do everything we can to do so, and researchers who participate in next year's event. Most importantly, we also hope that this will allow us to double GPDI's impact on the desal technologies and plants, cost of water, and sustainability. We, in the coming, well, I don't know if it would be weeks, but in the coming months, we also hope to make some additional announcement on some new categories that will provide some early stage technologies and some commercial or about to be commercialized technologies a chance to be judged against each other rather than lumping all of these new technologies together. And at the same time, we hope that we'll also be announcing, well, again, there's no hope, we will be announcing some categories that will address the social impacts of desalination and ways that we can increase the social awareness of the desalters and those of us who drink water on the impact desalination can have. So with that, I'd like to thank you for attending today and for bearing with us through all these presentations. And I know that that I've taken some, I'll have something to take back with me, and I hope you all will as well. Thank you.
Super, Tom. Thank you so much. Wow, it's been an amazing 4 days, huh? A lot of experts, a lot of knowledge, and I hope it was also a lot of fun. So we reached to the end of this conference, but to finish it properly, I'd like to invite on stage His Excellency's Deputy for Innovation and Research to deliver his final remarks. Please give it up to Tariq Al-Ghafari.
Hello, everyone. Hello again. And as we might have been hearing a lot, today is our last day, but it's actually the beginning of a new journey to move forward in the upcoming year. I would like to announce that the next year will be even much, much better, containing richer and more important subjects to cover. But at the same time, it will have the progress of what we have achieved this year or during this discussion throughout this event. I would like to thank you, all of you, for being here today and being part of this journey. And I would like to thank all the participants as well who were successfully applied and took the initiatives in the GPID prize. It's such an important event that we carry out. And I would like to also thank Evolve for announcing it's a new technology in here for us to carry this out and to wrap it up. We would like to end up with a picture of all of us, but to make it more efficient, I would like to ask the people who are in the back to come on the stage all the way until the end, so we invite His Excellency and the other deputies. So thank you so much, and let's make this efficient and take a wrap-up picture, and I would like to thank you again, and I will see you next year. Please follow up on our page and websites for both the IDD, Innovation Driven Desalination. Apply all your research, your thoughts, your innovations, and at the same time, follow us on the website of the GPID and apply your ideas so we can hit our targets, as maybe Tom was mentioning. So please, people in the back, let's come all on the stage. So people in the front then come back on the stage. Thank you.
طيب يا جماعة اللي ورا أغلبنا نحكي عربي. ممكن نتقدم للأمام ناخذ صورة جماعية بتواجد معاليه والفريق التنفيذي والخبراء والعلماء. Yes. Including المنظمين والمنظمات. كلكم بذلتوا جهود عظيمة. Please step forward. Including you as well, you should join the picture too, you know? Yeah, I know you're taking the picture, but we have people to do so you should join us. I'd like now to ask the executive team of SWEC to join the stage as well.